Hey everybody, this is Brian and welcome to the first Python tutorial. Been wanting to do Python for a while. I should dispel a few myths first. Everybody hears the word Python and they think this big evil monster snake, and I mean even the icon for it is like these two snakes in a yin-yang symbol, so everybody thinks of this little guy right here. It's actually not the case. Python's been around for a long time, and it was actually named after the Monty Python. If you have no idea who Monty Python is, I feel very sorry for you, and you should Google it because they're hilarious. Their comedy is actually timeless. But it's the whimsical nature of Python. It's the language has tried to emulate that. So if you go to python.org, we'll be working with the newest version, Python 3.43. That may actually date this video at some point if they drastically change Python. But you'll see it's available for Windows, Mac, Linux, and pretty much everything in between. And it even comes with full source code. Some things you should know about Python before we get started is they really say batteries included is kind of the lingo here for Python, and that's I've got to agree with it. It's very powerful and it's not very chatty. And what do I mean by chatty? Some programs you have to write hundreds of lines of code just to print something on the screen. Python, it's just dirt simple. And if you're in a university, a lot of universities are actually replacing Java with Python as the learning language. So I wanted to kind of get into it. I have a heavy security background, and Python's actually become the language of choice among hackers. Not all hackers, but a vast majority of them love Python because it's just very easy to work with and very powerful. Python does come with a built-in IDE called idle, which I personally cannot stand, especially for teaching purposes. So I'll be using JetBrains PyCharm. If you've watched any of my tutorials, you know that we just, take the seatbelt off and just dive headfirst in. And I'm going to kind of slow it down a little bit because I realize that being an introductory language, especially being taught at universities, and some of my videos are actually shown at universities, I want to kind of dumb this down as if this was your first programming language. Now, that disclaimer being said, I am not going to hold your hand through this whole process. We're going to take our seatbelts off and dive right in. So let's just go to it. Maybe, if I can find PyCharm. There we go. So we'll load up PyCharm. I'm using the Community Edition 4, which is absolutely free. And I'm just going to kind of move the window out here. I should note that you're going to need Python installed before you do this. And you'll know, because if you go to create a new project and you don't get a Python version here, then you need to do something about that. And what you do is you go out to python.org, download the version that's right for you. If you're on Windows, it's just a normal installer, click next, and you're done. If you're on a Linux, Unix, BSD, Mac, whatever derivative, you're going to actually have to compile it by doing, /configure. And if you've done this before, you've done this a million times. You just go into the directory, you do /configure, make test. Make test on my machine actually failed. But then you do sudo make install, and that actually installs it as Python 3. So you can open a command line here, and you'll notice if I just type Python, it says Python 2.7.6, which is the older version. So I'm going to Control D out of there. I'm going to do Python 3. And there's 3.4.3. That's the version we'll be working with right here. So just bear that in mind. If you have the old version of Python, you'll want the new version for these tutorials. And when I say old and new, I should really explain that. When you go out there, and let's actually just rewind here a minute. When you go out to Python, you go to downloads, you'll see you get the option between 3.4 and 2.7.9. The reason is back in, I want to say, somebody out there will correct me if I'm wrong because the internet's full of experts, but it's like Python 2.5. They actually made a radical change to the Python libraries. I shouldn't say radical. Radical enough that it broke legacy code. So they've kind of branched it off here. So they've got the old version of Python and the new version of Python. And there's some gotchas. So if you try to use my code with the old version, it just simply won't work because it doesn't understand what you're trying to tell it. So just bear that in mind. You'll need the newest version. Why am I starting off with the newest version? Well, eventually the old Python will get phased out and render my tutorials useless. So what's the point of wasting my time and yours? All right, so once you've got Python set up, if you're kind of like a little computer nerd like me, you're going to want to look and see what's in here. And you'll see there's the Python binary. And there's all the little files that it created. Pretty awesome, huh? And if you go out to user local bin, you'll actually see there's the symbolic link for Python 3. jumping back into PyCharm here. We're just going to pick the newest version. We're going to call this videos. Why not? And hit create. And ta-da, there's PyCharm in all its glory. I'm going to resize this a little bit here. Now, I know I'm probably going to get a million messages saying, why are you using PyCharm? There's better IDEs out there. You know, I tried a few of them, and I wasn't impressed with a couple of them, so I really liked PyCharm. I don't know what it is. I'm not in any way affiliated with their company at all. I haven't even bought the product. I just really like the IDE. All right, so first thing we're going to do is make a Python file. And we're going to call this, we need a descriptive name. Let's call it video 1, because this is our first video. And you see this author root shell. Well, that's my username on my computer, so I'm going to change that for future tutorials. And it puts that in there automatically for you. Now, we are going to do the obligatory Hello World program. And what do I mean by obligatory? In every language, your first introductory program is Hello World, where you literally just print Hello World on the screen. And it's this big, awe-inspiring thing, and there's harps and kittens and rainbows. And don't expect fireworks. It's actually pretty fast in this one. You just do parentheses and then quotes. Hello World. And we are going to actually right-click here and run video 1. And you'll see down here, Hello World. And that's actually why I chose PyCharm, because it's very easy to see what's going on. There's no magic behind the screen, and you can see everything that's going on here. And if there's an error, it'll print it out, you know, pretty plain English here. If you try this and you get an error message, it's because you're running the old version of Python, which is expecting something like this. Hello World. Which, as you can see, it's saying, hey, you know, end of statement expected. Now, if you don't know what a statement is or any of that, you're very new to computers. Don't worry, we're going to cover all this in future tutorials. That's it for this tutorial. Like I said, painless, no fuss, no muss. We're going to dive into these head first, and you really should go out to my website, voidrealms.com, and click on tutorials. And it's not there yet, but I will add a Python folder in here, and the source code for this and all the other tutorials I've done are out here. Also visit Facebook and join the Void Realms Facebook group. There's like 200 programmers in there, so if you have questions, instead of emailing me and waiting 6 months for me to find your email, it's much easier just to say, hey guys, I got a question. Well, thanks for watching. I hope you found this educational. And hey everybody, this is Brian, and welcome to the second Python tutorial. We're just gonna jump right back on in here. If you watch video 1, we did the Hello World program. We're going to kind of continue on with that. Make a new Python file here, and we'll call it the very descriptive video 2. And like I said in the intro, we're going to cover this as if you're very new to programming. So if you're a veteran programmer, you can probably fast forward through a lot of this and just kind of pick up the highlights. There are a couple little things, and I'll try to point those out. So in every program, you need to leave comments. And a comment is this, just a comment. It's you letting yourself know what you're doing. At some point, you're going to get stuck. You're going to write some big, long function, and you're going to want to write a comment saying, hey, this is what I did. The comment is not processed by the Python processor, if that makes any sense. Meaning, it's just a note for you. The program doesn't care, so you can type literally anything you want. Probably best to put a descriptive note. Comments are good, so always keep that in mind. We're going to save this little guy here. Now, the core of any program is a variable, and I'm sure your instructors, if you're in a university, have said, you know, a variable is this sector of memory that a pointer points to, and your eyes start glazing over and you start thinking about playing hockey or video games or Call of Duty or, you know, whatever. All you need to know is a variable is something that'll change. That's the actual literal scientific term for it. A variable is something that will change. In Python, variables are very easy. So we're just going to say, whoops, if I could actually spell first equal, and Brian's my first name. We'll say last equal, and Karen's is my last name. And age, oh boy, I don't know if I want to put this out on the internet. I'm 40 years old, and we're going to actually make a comment here. These are variables. Now, if you try running this, you'll see it does absolutely nothing. It just says we ran and then whatever the name of the script is, and finish with exit code 0. Exit code 0, does that mean it's an error? No, actually, code 0 means there was no error. Programs will return different codes, and those codes are usually called error codes. If you have Windows and you've ever seen the infamous blue screen, it's got some big garbly number, that's the error code. So exit code 0 is a good thing. What we're going to do now is we're going to learn how to print things out. We already did the hello world. We're going to say print in all its glory. That's what this tutorial is all about, is printing. So we're going to say print, and we've done the hello world. So that's nothing new. You can also print and do single quotes, hello world. And what's really the difference here? I mean, let's just run this guy. You can see it both prints hello world. What's really the difference? Nothing, actually. It's just personal preference. The single quotes make it easier to put a quote in the string, and the double quotes make it easier to put a single quote in the string. Because let's say you want to say David's cat. Notice how, oops, yeah, suddenly now we got an error. Unresolved reference cat. You'd have to put that inside of double quotes. That way it doesn't process the single quote. So if we run this again, you should see, yep, David's cat. So that's really all you need to know when it comes to that. My personal style is I typically do double quotes. You can change it however you want. So what happens if we want to print out a variable? Well, you may have already guessed. The reason why I use PyCharm here is it has this thing called IntelliSense. You see this little pop-up that keeps appearing? That tells you basic structure of what it's expecting. You see print, object, separator, in, file, flush. While I won't really get into that in this tutorial, you just know that what it's expecting is some object. Everything in Python is an object, is an object-oriented language. So we're going to say first, which is the name of this variable up here. Print a variable. And you see there's Brian, our variable. Now what happens if you want to print more than one variable at a time? We'll say print, and you can say, oops, first plus and plus last. I mean, you can do that. And a lot of people do that exact same way. And you see there's my name, Brian Cairns. But there's an easier and a more correct way, string formatting. And what you're going to do is a little bit of voodoo magic here, but we'll explain this as we go. We'll say print, and you're just going to do your quotes, and you're going to say, my name is, and you're going to do a %, and an S, which represents a string. I am %D for decimal, years old. Now, I'm going to save this and run it just to show you what happens. It says, my name is %S, I am %D years old. That makes no sense. What it's expecting is these are just placeholders. And that's the format symbol, or actually the percent symbol, saying it's expecting a string, it's expecting a decimal. A string is just an assembly of characters, like my name is a string. A decimal is a number. It could also be called an integer, floating point processor, etc., but basically it's expecting a decimal number. Now we need to do the % to tell it it's expecting a format. And we will need to give it what's called a tuple, which we'll explain that in a future tutorial. There's, like I said, a little bit of black magic going on here. We'll say Brian, Cairns, and 40. Run that, and you see, oh, what is this? Trace back most recent call, line 21. Let's right click here and get some line numbers. So line 21, if you actually click that link, it'll take you right to the line. A number is required, not str. That's what's going on. This is an error, and I want to kind of walk you through this, because when you're sitting at home and you're typing away on this, you'll make errors and mistakes, and it won't line up with the video, and you're going to go, well, what'd I do different? I kind of wanted to explain this. Trace back. That basically means it's going to trace back in the code. The file is the file we're actually running. The line is the line number, line 21. And if your cursor's up here in PyCharm, you can actually click it, and it'll take you directly to the line. And it'll say in module, something we haven't covered yet. And that gives you the actual code, print, blah, 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 blah. The type error, %d format. So we're looking at this guy right here, %d. Is a number required? You know, a number is required, not a string. So what it's really expecting is a number. Now suddenly it runs. My name is Brian, I'm 40 years old. Little mischievous on my part. I apologize if that was a little bit confusing, but I want to get you used to making mistakes. Part of learning is making mistakes and fixing them. People get very frustrated when they make a mistake. I want you to make mistakes. All right, so let's explain this code and let's really understand what this thing's doing. We have a string, you know, just a collection of characters, and inside that string we have some special things going on here. We have these formatting characters, the %s and the %d, meaning it's expecting a string and a number. Then we have the % sign saying, hey, we are formatting this string, so it's going to look for the % signs. And we're handing it a tuple, which is a list, basically, or an array if you're used to other languages, which is, think of it like a collection of objects. It can be numbers, letters, other objects, things of that nature. And we've got two of them in there, Brian and age. Now we can actually substitute that with, you guessed it, variables, first and age. These are the variables that we declared up here, first and age. Let's run that again, and you'll see, sure enough. And we can even modify this again. So we've got first, last, and age is what we're passing to this. My name is Brian Cairns. I am 40 years old. Whew, that's a mouthful there. So that in all its glory is string formatting and how to create and hopefully resolve and fix an error message. A lot of this is pretty intuitive, but let's say you just kind of like goof something up, like let's add a little, you know, something there. You'll see the little red squiggly, and maybe that's not the best one. Let's just add some garbage in there. Yeah. You'll see the red squigglies. A lot of time you can just mouse over and it'll tell you what's going on, unresolved reference to, and you can click on a little more and it gives you a detailed explanation. That's part of why I chose this IDE, because I see a lot of people learning Python struggling with the built-in idle, and it's really not meant for beginners. I'm sorry, it's just not. All right, so we've made a variable. We've printed the variable, and we've shown different ways of printing it. One thing we really haven't covered is string processing, which we're going to do in the next tutorial. What do I mean by string processing? I want to cover this in this tutorial because I want to solidify what we just learned about variables. A variable is something that'll change. Python's an object-oriented language. You hear that a lot, but what does it really mean? Well, an object is an instance of something, meaning it's a variable. Everything in Python goes down to what's called an object or a base object. If you've learned Java, you're familiar with this concept. So just think of object as like a widget. It's just this thing that exists, and everything grows upon that. So the variable's an object. You're an object. Your cat's an object. Your dog's an object. Your computer's an object. Everything's an object at some point. So with objects, you can actually manipulate those objects and change them. And that's what we're going to do in the next tutorial, string processing. Well, I hope you found this educational and entertaining. Please visit my website for the source code to this and all other tutorials. It's voidrealms.com. And I can't stress it enough, join the Void Realms Facebook group. There's like 200 of us in there. It's a lot faster and easier to ask, 200 people for help than to email me and wait, well, months, years, decades, centuries for me to respond. Hey everybody, this is Brian and welcome to the third tutorial with Python. We're going to cover string processing. So let's actually close these other tutorials that I've done. I think this is going to be the last one for tonight. I had steak for dinner and I'm starting to go into a food coma here. So video 3 is going to be the very descriptive name of this thing. And we're just going to call this Super Awesome Time with Strings. So I'm just going to make a variable and we're going to say hello world. And because I really detest the hello world tutorials, we're going to just chop this thing up and have all sorts of fun with it. So we know what a variable is. We understand that a variable is something that'll change. We understand that things in Python are objects, and with objects we can do things. And that's what this tutorial is really about, is doing things with those objects that we create. Does that sound confusing? It is kind of confusing, and that's why I hated computer science classes, but it's actually a very simple concept. So the first thing we're going to do is we're going to print the length of a string. And my super awesome spelling ability, we're going to print, and we're going to say string is %d bytes long. And you remember this from our last tutorial. Now we're just going to say len, well, maybe, len str, and str is our variable. So we're calling the len function. We'll cover functions in future tutorials, but a function is just a collection of code that runs inside of a scope. Super confusing, I know, but it'll be very clear once we get there. And we're going to just print this out. So let's run this. The string is 11 bytes long. Now if you want to pause the video and count that, I can guarantee you it's going to be 11 bytes. Don't include the quotes. Now we're going to make that uppercase. Oops. Now, one thing you should know, when I hit that dot, or the period, you'll see it gives us a list of things. This is why an IDE is super helpful, especially when you're learning, because you don't know all these things and you don't want to spend hours memorizing the help document and stuff. You can just, hit the period and it says, oh, these are all the things you can do. Capitalize, count, and code ends with. And a lot of times it'll have a very, kind of descriptive identifier next to it. So in this case, we're just going to say upper, and we're going to make it lowercase. We're going to say print lower. Now, you know this little self here. What does self mean? We're going to cover that in a future tutorial, but a self is a reference to the object you're currently in if you're in a class. We're not in a class, so it just ignores it. We're going to run this. You're going to see, sure enough, the string is 11 bytes long, hello world capitalized, hello world lowercase. And we are going to, let's have some fun with this. We're going to find the position of a letter. Actually, let's change that to index. We're going to find the index of a letter. Now, what do I mean by index? Think of this as a list. There is 11 bytes in here. The list is zero-based, meaning this is position 0. I don't know if this is going to show up in the video. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Because it's 0, if we call 0, we're going to get the letter H. If we call 1, we're going to get the letter E. We don't know where that is and we want to find it. So let's say we want to find the position of the first O. So we're going to print the position of O is, and we're going to %d here because it's going to return a number, and we're going to say str index O. Now what does that do? Let's run this and find out. The position of O is 4. Well, if we count this out, 0, 1, 2, 3, 4. That's where O is, right there. It's the 4th character. I should say it's the the 5th character on the 4th position because it's the 0-based index. I want to cover that one more time. 0-based index, meaning everything starts with 0. Seems like a foreign concept. You think the first one would be 1, but no, it's actually 0. Super confusing. It's one of those things you just got to learn to live with. Another thing you got to learn to live with is, let's say you do a capital O and you run this. You'll see you get an error. Traceback, recent call, blah, 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 the code, value error, substring not found. It couldn't find O because it is, you guessed it, case sensitive. So we're going to actually change this a little bit. String that upper index, and we're going to say O. What we're doing here is we're taking the string, making it uppercase, which we've already done, and then finding the position of the letter O. And this time we run, and you guessed it, it's at position 4. Two very important concepts there: 0-based and case sensitive. Those are two things that I guarantee will trip you up as your career in a Python programming. All right, now we're going to count the number of L's. And let's just put that in there. That way it's more descriptive. There are %d letter L in the variable. I will say in %s. And all right, this is what we're going to do here. We're going to make a tuple, and we're going to say str.upper.count. And you guessed it, we also need to give it the variable, because what we're doing here is we're going to say there are however many letter L's in the, and then we're just going to print out a string. There are 3 letter L's in hello world. This might look confusing, and I want to explain this a little bit just in case you're sitting there scratching your head. What we're doing is we're string formatting like we've done in the previous examples, and we're making a tuple. Remember, a tuple is just, it's a list of objects. Tuple and list are not used interchangeably. We will cover this in a future tutorial. The difference is a list can be modified, a tuple cannot. Now, the first item in the tuple, think of it as like a book. You're on page 1. The first thing is, well, we're taking the string, making it uppercase because remember searching is case sensitive, and we're counting the number of letter L's. Or number of letter L's, boy I am tired. We're counting the number of L's. The second one in our tuple is just the variable itself because we're going to print that out here. That's how we get there are 3 letter L's in hello world. Now we're going to do some slicing. What is slicing? Think of this string as a loaf of bread, and you want to slice this into certain chunks. Like you want half the loaf or a third of the loaf or just one little slice. We're going to print str, and then we're going to do these brackets here. And we're going to say 3. Looks very foreign to us. What does this mean? We're taking the string, and then on position 3, we're going to print that out, which should be that L, that first L. So let's run this. Sure enough, there's the L right there. So we're taking a slice. We're getting just one little slice. And then we're going to just play around with this and just get really insane with it. We're going to say we want 1 to 4. What this means is we're going to start at the first position and we want 4 characters. Let's run that. Or I'm sorry, we want to go to the 4th position there. Nope, yeah, we did. Let's go to 6 just for more descriptive purposes. Yeah. Pretty simple, pretty easy to understand. Now we're going to go print. And we're going to go, let's go the 0 position. Actually, let's do this. Let's go 1, meaning we're going to start at the first. Remember, this is 0 base, so we're skipping this H here. We're starting at position 1, which is that E. And we're going to go to the length of the string. So we're going to read the entire string. Now I'll let you pause the video and take a wild guess what this is going to do. If you said it was going to print the entire thing minus the first character, give yourself a gold star, because that's exactly what it did. Now, whoops, we want to split this. Splitting a string is very handy. Like, let's say someone gives you a name and you want to split it into 2 variables. So we'll say name equal, and we're going to make a new variable here, Brian Cairns, and just, type your name. You don't have to use mine. And we're going to print, and we're going to say str split, whoops, and we're going to split based on spaces. So what this is going to do is it's going to actually create a new object. I believe it's going to create a list, and it's going to use the space as a splitting point, meaning if it's not a space, it becomes its own unique object. Whoops, help if I did the right variable. There we go. So you can see now we have a list with Brian and Karen's inside of it. To kind of solidify that, let's say my list equal name split. And we're going to split on the space. And let's actually just print out my list. It's going to print the same thing. But we're going to say print, and we're going to get just a little crazy here. My first name is %s, and my last name is, you guessed it, %s. And we're going to format that. Actually, I've never tried this, so this may explode drastically, but let's try this and see what happens. Oh, yeah, not enough arguments. All right, so we're going to actually do this. So what we're doing here is we're creating this list, which creates 2 unique variables because we're splitting the string into 2 different things. Remember, the split point is the character we defined. In this case, it's a space. We're going to print that out, and then we're going to print my first name is, and then whatever the first item in the list is, and my last name is whatever the second item in the list is. Remember, this is 0 base, so the first one's always 0 and the second one's always 1. Super confusing, I know. Drives people just insane. And sure enough, my first name is Brian, my last name is Karen's. Whew, that is a lot of work. And if we were doing a different language, like say C++ or Java, that would be probably about 4 or 5 different tutorials, and we'd be about 2 hours in discussion. This is what I mean by Python comes with batteries included. It's very powerful, and you can do some pretty complex things very quickly. Now, don't beat yourself up if you're having a hard time wrapping your head around lists and things like that, because we just simply haven't talked about them yet. But we're going to get to them very soon. That's all for this tutorial. Thank you for watching. I hope you found this educational and entertaining. The source code for this and other tutorials will be out on my website, voidrealms.com. And I know I'm kind of beating a dead horse here, but be sure to join the Facebook group called Void Realms. There's like 200 programmers in there. And I see a lot of people coordinating and helping each other out, and it's a lot easier than trying to get a hold of me. Hey everybody, it's Brian. This is the fourth Python tutorial. We are going to go over a few different things here. So first thing we're going to do is make a new file, and we're going to call this the very descriptive video 4. Now, the first thing we're going to cover is going to be lists. We've talked about lists and tuples and things like that, and I keep saying we're going to get to it, we're going to get to it. Well, guess what? We're getting to it. So we're going to talk about lists. Now, what is a list? If you're familiar with other languages, a list is an array. In short, if you're not familiar with other languages, well, what is an array? Simply put, think of it as a box, and in that box you can place things. Like, actually, let's call this mlist, and you need these brackets here, and we're just going to say 1, 2, 3, 4, 5. That's a list. So think of it as a box that you can place things in, and in this box we have 5 things. Now, you've heard me talk about zero-based. That's your first indicator that it's an array. Most languages, arrays are zero-based. You can pretty much use the term array and list interchangeably. So if you hear somebody say, oh, I was working with an array, they're working with a list. If you hear somebody says, I'm working with a list, they're working with an array. Pretty much similar concept. Obviously, when you get into different languages, they're treated differently, but down in the nitty-gritty, they're pretty much the same. The cool thing, however, about Python is you can actually put things of different types in here. So you can also say, like, let's see, let's redo this whole thing. I want to really get crazy with this. Let's say 5, 2, 1, 4, 3, and then we're going to say dog, cat, and yeah, why not bird, because I can hear my girlfriend's bird in the background squawking away. I don't know, can you guys hear that on the video? That's like super loud. I can hear it through my headphones. Anyway, so we're just going to print the list. Save that, let's run it. And you can see it just prints out pretty much what we just typed in. That's exactly what it looks like in memory. As far as Python's concerned anyways. I know the C++ people are like, no, that's not what it looks like, but we're in Python land, so when in Python land, do as the Pythons do, or Romans do, or whatever the saying is. All right, now, why would you want to create a list? You know, you've got this box, you've got things in it, what can you really do with it? Well, think of it in terms of like a line at a bank. There's 10 people in line. Each one of those people is unique, but you need to treat each one of those people as an individual. And that's what you can do with a list. You can actually do some pretty cool things. Like we're going to count the number of cats, because I really like cats. Print, and we're going to say there are %d cats. And I've had a very long day, but a very rich and rewarding day. So I might make a few mistakes. Now remember from our previous tutorials, this is case sensitive. So if you do cat, that's not going to find it. Remember, everything's case sensitive. So let's run this. There are 1 cats, because there's 1 cat in there. Now if we were to just, you know, through the magic of copy and paste, let's just throw a cat in here somewhere. I like saying that. Let's just throw a cat in there. There you go. There are 2 cats. I mean, some programming languages are like trying to herd cats. So anyways, so you can count the number of specific objects in there. You can also get the length. Whoops. And let's just do this. We'll say, whoops, %len and mlist. I'm pretty sure that's how that works. Yep, there are 8 objects in the list. And if you count those out, there are 8 of them. Now, let's say we want to find the specific position of something. Like we want to find that pesky cat. Find the index of the cat. Now, what is index? Well, items in the list are indexed, meaning they have a number in memory. the first position is 0, then 1, 2, 3, 4, and on and on and on. It's always 0 based. Remember that. It always starts with 0. So we want to find where is this? What's the index? What position is it in? And we're going to say print. The cat is at index, and we're just going to do %d, %, and we're going to say mlist index, and we're going to find that cat. All right, so run this again. The cat is at index 6. So if you count this out, remember it's 0 base, 0, 1, 2, whoops, 0, 1, 2, 3, 4, 5, 6. So we're at the 6th base. Whew, all right, we're not done yet. Lists actually have a lot to them. So we're going to actually insert an item into this list now. And if this tutorial gets too long, I might break it up into a few videos. I've been trying to keep them a little bit shorter. I've had people tell me, hey man, I watch your videos on my cell phone and they get a little bit too lengthy. So insert, and we're going to insert at position 2, or I should say index 2. We're going to insert a fish. When was the last time you really wanted to insert a fish into anything? Really think about that. All right, so we're going to now print out the list and see what happens here. And you can see at position 2, remember 0 base, 0, 1, 2, we now have a fish. Now we're going to append an item. Append just means add it to the end. You'll hear that quite a bit, where I'm going to append a file or append an index or append an array or whatever. Append an object. All right. Mlist, whoops, cannot type today. Append, and we're going to add a snake. And we're going to print out the list here. You'll see, sure enough, now we have a snake at the end of our list. Now we want to remove the item, because I'm not a big fan of fish. I'm more of a steak and potatoes kind of guy. Remove the fish. And we're going to say mlist.remove. And remember, case sensitive here. And now the fish is now missing. See? Now let's get a little crazy here. Let's say we want to reverse this. And we're going to say, let's see here, mlist.reverse. And then we're going to print it out. So now the list is exactly reversed. It's a mirror image of what it was. Notice how reverse actually took our existing list and modified it. So if we were expecting, cat to be at a certain index, it is now at a different index. And you can test that by, running that yourself, saying, what's the index of cat? And we can actually just copy and paste that there and run this again, and we'll see the index of cat is now at 2. So you got to be a little careful when you do things like reverse. So what we're going to do next, and I'm just going to add some space here, is we're going to slice and sort. And this is going to be the end of our little list here. Remember, a slice, we're talking about like a loaf of bread. You can take a chunk or a slice of the bread out of the loaf. And that's exactly what we're going to do here. So we're going to make a new list, and we'll call it nList. Actually, let's call it new list. That way it's not confusing. And we're going to say mlist.copy. And what we're going to do here is we're going to actually just make a complete copy of that, a mirror image, if you will. I shouldn't say mirror because mirrors are reversed, but you know what I mean. We're making a clone of this thing. Now we're going to take the new list and we're going to reverse it back to the way we wanted it. And we're just going to say new list equals, and this is going to blow your mind a little bit here. New list, and we're going to actually slice this thing. And we're going to say 0 to 5. And then we're going to sort it. And you're probably going, what in the heck is he doing? Well, we're going to explain this here super quick. So what we're doing is we're taking our existing list, we're making a copy of it, shoving it into memory as new list. We're taking new list, which is a copy of that, and reversing it. So it'll now be back to this way right here. We're then slicing. We're saying from index 0 to 5, get another list. Now, what we're doing is we're taking our new list, slicing it, and adding that new list into that memory. What does that mean exactly? It means we're overwriting that variable. Remember, a variable is something that will change. You could very easily create an entire new variable called my new slice or something, but I just wanted to show you that you can actually do that to variables. Now, because we've gotten 0 through 5, we're pretty much only going to get these numbers. Then we're going to call sort, and it's going to print out the new list, which is going to be 1, 2, 3, 4, 5. Fingers crossed. Let's see what it does. Yay, it worked. There's our new list right there, 1, 2, 3, 4, 5. Now, in case you're curious, you cannot call sort on mixed types. You'll have to have some way, and I believe we're going to do this in advanced tutorials, of telling it how to sort, but it's much more advanced than where we're at right now. That's why I took out the bird, the cat, the dog, the snake, and et cetera, et cetera, et cetera, because it would throw an error in there. So let's just demonstrate that. Let's say new list dot append, and we'll say kitty, because I like kitties. And let's try running this, see what happens. Yeah, see, we get unsortable types. There you go. That's why I took that out. So I think we're going to try and keep trudging along here. We're doing pretty good on time. I want to cover tuples. So let's just call this, actually I can probably just keep it all in the same file. Why not? Let's do this. Let's go. So we know that we're switching up here. Now, we've worked with tuples before, and you're probably like, what in the heck is a tuple? Well, I'm going to copy and paste some stuff in here just to save time. I like that sound effect. Anyways, this is a multi-line comment. It's just triple quotes, a tuple. And I actually got this from learnpython.org, and I don't think I could have worded this any better. Tuples are fixed size in nature, whereas lists are dynamic. Meaning, once you create a tuple, it's not mutable, meaning you cannot change it. It's read-only. Yes, I'm going to repeat that. It's read-only, meaning you cannot add elements. You cannot remove elements. You can, however, find elements since it doesn't change things. You can also, in the operator, check to see if something exists. Now, why would you want a tuple? Well, in case you wanted read-only. You'll notice a lot of the functions we've been passing things to are tuples. We're passing read-only information. We don't want that function to modify the information we're passing it. So let's just make a tuple here, and we'll call it my tuple. And the syntax for this is very scary. Are you ready? We're just going to go 1, 2, 3, 4, 5. Notice that's the difference right there. A list has the brackets, tuples has parentheses. That's it. That's all there is to it. Now we're going to print it out. We're going to print my tuple just so you can see, at the very end, 1, 2, 3, 4, 5. And let's just add tuple. That way we know it's different. There we go. So that's our tuple. And you can even see in the little window here the list versus the tuple indicator. So you can plainly see they're different. Now, as you'd expect, because this is not mutable, meaning we can't change it, when you hit the period after the variable name, there's a lot less options here. We can count and we can index, which we've already done in lists, and they're the exact same syntax. But that's pretty much it. I mean, you can iterate over them, but that's pretty much, you can't really add or insert or anything like that. So you can say, you know, let's just do it. Print index of 3 is I got distracted, sorry about that. It's going to happen from time to time. Oops. Let's run this. So the index of 3 is actually 2 because remember this is 0 based. So pretty much everything you've learned with lists, you can apply that to tuples minus anything that's going to modify that list. You can't add, you can't remove, You can't modify the item, etc., etc. One thing I probably should back up here. Let's actually just do this. Modify an item in list. How would we do that? So let's say new list. We're back in list mode. Sorry, we had to back up here for a second. And you can access it by its index. And this is why index comes important. So we're going to take that first item because it's zero base, and we're going to say LOL. Why not? Just, because it's been one of those days. I hear my daughter say that all the time. LOL, LOL. And when we run this, you'll see, because we've reversed, it's our last list, there's LOL. So that's how you would modify an existing item. You call it by its index. Now, if you try to do that with a tuple, let's actually just, through the magic of copy and paste here, and we'll change my tuple. And we're going to try and modify this tuple here. What do you think is going to happen? Yep. Tuple object does not support item assignment, meaning we cannot modify this. And I'm actually going to leave this in the file. Bad. Will not work. And I'm going to comment this out here. Just to kind of solidify that a tuple cannot be changed. Whew, you think we're done? Nope, we're not. We're going to cover dictionaries. Now, what's a dictionary? Did I spell dictionary right? We're going to say that I did. I had eye surgery, so I no longer need glasses, and sometimes things get really blurry, and if I stare at a word too long, it gets very blurry, so forgive me if that's misspelled. All right, so what is a dictionary? Think of a dictionary as a list on steroids. So we're going to say ages. And we're going to say ages is, and we've got yet another type of bracket. I don't know what that's really called. I'll call it a bracket. Why not? Brian. And then we're going to add a semicolon, and we're going to say 40. And then a comma. Notice that comma separates things. I'm going to say Heather, which is my daughter. And she's 22. And we're going to print eye surgery. I'm going to blame everything on the eye surgery from now on. In case you're wondering, eye surgery was expensive, but it was well worth the money. I actually did a video on it. If you haven't seen it, I recommend you go watch it. All right, let's run this. And at the very end, you'll see here is our dictionary. Now, what's going on here? This looks a little different. We've got these brackets. We've got a string and an integer separated by a semicolon. Well, what's going on here is we're actually assigning our own indexes, or keys as they're called. To kind of solidify that, we're just going to print ages.keys. So we're only going to print the keys. Notice how it returns a dictionary of keys, Heather and Brian. So what we're doing here is we're replacing the index, which this guy right here, the number, we're replacing that with an actual object. And it can be anything. It can be a class, it could be a string, it could be a number, it could be whatever. So now we don't have to remember position 0. We can do some pretty cool things. Look, let's actually just finish this up here. Print ages.values. We can also print the values out, and we're going to print ages items, just to give you an idea of what's really going on here. So the keys are there, the values are there, and the items are, well, you guessed it. Now, notice how these are tuples. Kind of neat, huh? But what you can do here is you can do things like, let's say you want to print a specific item. Like, let's say print ages Brian. What do you think that's going to print? Well, it's going to print the value at Brian's index, or the key. So it's going to print 40. Sure enough, there's 40. So that's how you can do that. So you don't have to remember, okay, well, this is at position this is at position that. No, you can assign your own keys. It's pretty sweet, actually. All right, so we're going to now add an item. Actually, let's delete. Sorry. We're going to say del ages whoops, Brian. And remember, these keys are case sensitive. Everything's case sensitive. You should also remember that. And we can, and I'm going to add a note behind here, can use pop. Now, what does that mean? Well, delete's just going to delete this key with the associated value, and pop will delete it but also return it. We don't want to return it, so we just want to delete it. Kind of confusing? All you really need to know is if you want to return it and delete it at the same time, use pop. Otherwise, just use delete. And we're going to actually print this out when we're done. Why not? And now you can see that the only thing in our dictionary is Heather. Well, that's no good. My daughter gets lonely, so we're going to add an item back in. Add an item in. I can tell my eyes are getting tired. That's one thing I didn't like about the eye surgery is now my eyes get like very tired very quickly. It makes video games kind of a challenge. To add an item in, you pretty much just call a key that doesn't exist and assign it a value. And then we're going to say print ages items. And now Brian's back in our dictionary. Now, modify a value. Let's say ages Brian equal 99. Why not? I'm not that old, but print ages. What do you think is going to happen here? Let's run it and find out. Brian is now 99. Now you might be a little confused because when you print this out, you'll see that it's a tuple. And you're like, now wait a minute, you cannot modify tuple. You just explained this. That's true. What I've just given you is the dictionary items. This is what it's going to return from the function. But internally in memory, it's a list. It's actually two lists, and then it manages what points to what. So you can actually modify it. Whew, what a mouthful. Well, we've learned quite a bit in this tutorial. We've learned about lists, we've learned about tuples, and we've learned about dictionaries. And we've learned how to use them pretty well, I might add. There's still a ton more out there to learn, but that's all I'm going to cover to this tutorial just for the sake of time. I'd encourage you to go out to Google and do a little research on your own. Also, be sure to check out my rest of my YouTube channel. I've got tutorials for other languages as well, and I've got, oh my gosh, almost 5 million views. I haven't looked at this in a while. Man, my website is run off donations. So imagine if everybody that viewed donated $1, I would be retired. Anyways, voidrealms.com. I haven't put it up yet. I've been really busy, but you can find the source code for this and other tutorials. And there is a Void Realms Facebook group with almost 200 of us in there. I'm hoping to grow that because I see a lot of collaboration and people just helping each other out. Well, that's it. Talk to you later. Hey everybody, it's Brian and welcome to the 5th Python tutorial. Before we begin, I kind of wanted to point out on Python's website, because I've already been getting questions, there is a full set of documentation on their site. They even have a beginner's guide, a developer's guide, and even non-English documentation. So if English isn't your primary language, you can find a lot of good stuff out there. And I mean a lot of it. I mean, there's just tons and tons and tons. So, all right, without further ado, let's just jump into PyCharm. And we're going to make a new Python file, the very descriptive video 5. What we're going to cover today is going to branch off from what we've been learning. We're going to build upon everything we've learned. So far, everything we've learned has been a very simple one-liner, print something. Well, we're going to embark on a journey, if you will. We're going to learn about conditions. Usually, when someone has a condition, it's not a good thing, but in programming, a condition is a very good thing. A condition is like an if statement. If I'm hungry, then go to the kitchen, get something to eat, that kind of thing. So that's what we're going to learn today. Before we start with conditions, we have to learn about scope. So what is scope? And I'm going to say Java. That was embarrassing, can't spell Java. In Java, you'll have these brackets. It's called a C style language, and if you've tried these before, you probably don't like the brackets. I personally love them, but the brackets are there for a reason. You'll have your statement. Don't worry if you don't understand what that means. You're just saying if, and then you got start bracket, end bracket. Now you're looking at this from a Python perspective. Well, that's a dictionary. No, that's not a dictionary. That's scope. What we're saying is scope 1. There's actually scope 0, and there's actually 3 scopes in this little picture here. So what is scope? You remember how we talked about variables and something that'll change? Well, a variable is controlled by scope. And what I mean by that is if you declare a variable here in scope 0, it's available in scope 0, scope 1, and scope 3. If you declare it in scope 1, it's pretty much only allowed in scope 1. That being said, that's what these brackets do. They tell you that, hey, this is scope. There's something in here. So you can have, and let's actually just make another Java if statement here. Let's kind of format this correctly so we can see what's going on. There's actually, scope 4. So what you can do now is you can define a variable in scope 0, and it's available in all the scopes. You can define it in scope 1, and it's only available in scope 1. You can define it in scope 4, and it's only available in scope 4. That keeps things very, what's the word I'm looking for, encapsulated within your code. Now, Python does away with these little brackets that people just seem to hate. But you notice how things are indented here. Like, actually, let's nestle an if statement in here. This is about what it would look like. So now we've got 5 scopes. You're probably going, why is he showing me Java? This is a Python tutorial. Well, I'm doing it simply because these brackets are very illustrative of what's going on. You notice how things are indented, and you get this little line in PyCharm that shows you the indentations. Python does not have these brackets. Python works with what's called white space. Uses white space specifically for scope. For example, let's get rid of these little brackets here. And you begin to see what a Python program would look like. You notice how things are indented. That tells you right there, that's your scope. And PyCharm draws this beautiful little line to say, hey, here's the scope of this, here's the scope of that, here's the scope of this, etc., etc. Pretty neat, huh? Well, if you're coming from other languages, that's going to be very confusing, and that's why I wanted to really illustrate that. So we're going to make an if statement, a condition. We're going to really hammer out the if statements this tutorial. We're going to say x equals, why not 9, if x equals 9, colon. And then we're going to print 9 is here. Now, there's some things you should be aware right off the bat. Notice how the double equal sign. If you have a single equal sign, you're actually assigning a value. You're saying x is now 9. We want double equals. That's how we say if it is equal to. We're not saying it is equal. We're saying if it is equal to. A little bit confusing, but you got to understand that. You need this colon here. And then there's our print statement. So what we're doing here is we're defining scope. Notice how my little cursor stays on the scope line. Python uses this white space to determine scope. Keep that in mind at all times. Let's actually run this. And so we've got 9 is here and here. All right, pretty neat. I'm actually going to get rid of the and here just because it's bugging me. And then we're going to show inequality. Somebody emailed me last night and said, hey dude, your keyboard's like insanely loud. I'm like, yeah, but I really like this keyboard. Once you get used to a keyboard, it's really hard to just go somewhere else. If x, and then we're going to say the not operator, not equal to 9. Don't forget that colon at the end. Print 9 no more. Now remember that x is now 8 because we're assigning it. And we're saying if it's not equal 9, then we're going to print something. 9 no more. Some common mistakes you're going to make, you'll forget the colon. And then you go to run this, and then it's going to go, boom, syntax error, invalid syntax. And then you're just sitting here going, what? Just bear in mind, pretty much rule of thumb, anytime you're going to make a scope, you need that colon in there. Now, remember, x equals 8. Actually, just so I don't confuse you guys, x equals 8. And we're going to get a little creative here. We're going to say, if x greater than 10, and we're going to say else. Now, what's going on here? Some of you that are into other programming languages already know and going, oh my gosh, this is so boring. And I apologize, but we got to start somewhere. We're saying if x is greater than 10, then run this scope. Else, meaning if it's not greater than 10, run this scope. And it is, of course, less than 10. So we ran this scope, but not this one. That's where scope comes into play. You make a condition. You determine which chunk of code to run. That's the basis of polymorphic algorithms. You can decide based on a number what happens. For example, if we were to change this to x equals 3. No, actually, let's say 30, because we want to show that it's greater than. Now suddenly it's greater than. That's polymorphism right there. Now we're going to show Boolean operators. And we're going to say name equal Brian, age equal 40. I think my girlfriend just got home. If name equals Brian and age equal 40, remember the colon at the end? Whoops, misspelled that. There can be only one. Else, whoops. You are not Brian. You don't have to use my name and age. You can use your own just for illustrative purposes here. So what's going on here? We're doing and. And is a Boolean operator. We're anding in memory. In other languages, it looks like the double ampersand. But in Python, it's just literally the word and. So we're saying both of these have to be equal. The name has to equal Brian, and the age has to equal 40 in order for this scope to execute. Else, this scope will execute. Let's run that. There can be only one because, sure enough, Brian and 40. Now, if I change that to 41, you are not Brian. Let's change that back. Now, we're going to do the magic of copy and paste here. We're going to say age equal 21. And we're going to do the OR operator here. And we'll say, you and I have something in common. We're going to say, my mouse would quit acting up. We have nothing in common. So we're going to OR here. And in other languages, it's this double bar. But in Python, it's just the word OR. We're changing age to 21, so now it's not going to work with the and. So you're going to say either the name is Brian or the age is 40. If so, you and I have something in common. Otherwise, we have nothing in common. You and I have something in common because name's still Brian. Now, if I change this name, you and I have nothing in common. You can see how that kind of works. And let's kind of dive into lists a little bit here. We're going to do a little list checking. And we're going to say, let's change that variable x to dog, cat, fish. Maybe if I can do that right. And we're going to say if cat, we're going to use the in operator. Print, we have a cat. Else, print, no cats. How sad. Why not? Because I really like cats. Sorry all you dog lovers out there, I just really like cats. So we have a cat because there's a cat in X. The in operator will literally search that for you. I'm pretty sure under the hood it's just calling index of, and if the index of is not throwing an exemption, then it's doing something. So we're going to take that cat out of there and run this again. No cats, how sad. So you can see how the in operator here works. And we're going to do the is operator. Now this takes a little bit of explaining. I'm going to make two lists here. A equal, and I'm going to literally copy and paste this here. So we have two variables with the exact same values. And I'm going to say if A equal B, then print they are the same. Else print they are not the same. And don't forget your scope there. Let's run this and find out what happens here. They are the same. Now, that's the equal sign. We're going to do is. The is operator is a little bit different than equality. Is determines if it's the exact same object. And when we run this, they are not the same object. They're the same, but they're not the same object. What that really means is they have the same value, but they are two different objects in memory. So when you change A, it's not going to change B. Now if you say A equal B, guess what's going to happen? They're still not the same object, because what we've done is we've copied from one to the other. So you can still interchangeably modify those in memory. Pretty crazy, huh? Now, just because I know I'm going to get an email, we're going to say nestled if statements. How do you make a statement within a statement? Well, usually you join an activist group and grow your hair out long and hand out pamphlets at the airport, but we're going to just stick with the if statement here. So let's make I need some more variable names. Let's go name equal Brian, age equal 40. Well, they're not new variables. I just want to illustrate what's going on here. And pet equal cat. Why not? So we're going to say if name equals Brian. Notice I forgot that. And what I typically like to do is just flesh out my scope first. That way I don't get confused what's going on. And these don't have to be on the same lines. You can space things out. If age equal 40. So So that, in a nutshell, is what a nestled if statement looks like. And you can keep going and going and going. For example, whoops, if pet equal cat, I like that. You have a pet cat. Print, go get a cat. All right, so what's going on here? Let's explain this nestled if statement. This really demonstrates scope in Python. Remember how I started this whole conversation with the brackets? Well, if we were in another language, there'd be brackets all over the place. Python does away with that. We just have white space. You can see that line showing, hey, here's the scope for this, here's the scope for that. Just because they're on the same line does not mean they're the same scope. For example, that scope and that scope are different. You have to really know where you're at. Now, why does Python do this? Why does Python make this drastic change from other languages and not follow the brackets, the C style? Well, for a couple reasons. First off, it's a lot less you have to type. Also, there's no hard fast rule in other languages saying you have to indent. I've seen people do things like x equal 4 something something, do something, blah, 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 blah. And you can get some really just gnarly, unreadable code. And you got to look at this brackets going, okay, that's that scope. That's that scope. That's calling this function. And Python does away with all that. And it says, you know what? It's going to be maintainable. It's going to be readable. And it's going to be future-proof. Now, what does future-proof means? It means when you come back to this code 6 years from now and you don't remember what you wrote, you can go, oh, well, here's that scope. And okay, yeah, it just follows along. Your brain just follows it and you understand. So we've got our nestled if statements, and this is a beautiful example of polymorphism at work. We've got 3 variables, name, age, and pet. Name equal Brian, so it's going to print hello Brian. Age is 40, it's going to say you are 40 years old. If not, it'll say you're not 40 or you're not Brian, depending on what we've changed. And then we've got our, cat. So let's run this. Hello Brian, you're 40 years old, you have a pet cat. So we'll say, instead of cat, I have a dog. Go get a cat, because it's running this scope and not that one. And if we change this to, we'll say 30. Hello, Brian, you are not 40 years old. So it just skips over this whole chunk. Whoops, this whole chunk. And runs, you are not 40 years old. It's a pretty good example of nestled if statements and polymorphism. Well, that's all for this tutorial. Be sure to visit my website, voidrums.com. I actually did get a chance to go out and put the Python tutorials out here. So I've got the source code for this and other languages out there as well. This site is funded by your donations, so if you're not hurting for money, feel free to donate $1 or $2. Also, join the Voidrums Facebook group. There's 200 of us out there, and we love to help each other. Hey everybody, this is Brian, and this is the 6th Python tutorial. Just had an earthquake. It's kind of weird because I live in Michigan, and we really don't have earthquakes here. I think that's the second one I've felt my whole life. Kind of weird. So, anyways, I was right in the middle of doing a video when it happened, so I have to start over, which bothers me. So today we're going to discuss loops. Before we dive into loops, I want to revisit scope. Let's actually just make a list here, and we're going to make a blank list. And we're going to say for I in range, and I'm going to say 10. The range command just makes a range of numbers. And you're going to x append, we've done this before, where we're adding to a list, and we're going to print x. And I'm going to just run this, just so you can see what goes on. We're making a list, and each time it jumps into the loop, it's expanding the list by adding, see? But before we really discuss it, I want to discuss scope, because the last tutorial, we said this would be scope 1. Let me actually comment that out there, which means this would be scope 2. and this would be scope 3. Now I know some of you are actually sitting there going, wait a minute, scope 1 and scope 3 are actually the same scope. Well, you're right. You're absolutely right. I wanted to show the steps 1, 2, 3 for illustrative purposes, but the reality is they're the exact same scope. There are some gotchas, however, you need to be aware of. Like, let's say you want to print a variable called name, and because it's the same scope, you want to do it down here. You're going to say name equals Brian. If you try to run this, it says name not defined. You even see the little red squiggly line here. So you have to define your variables before they can be used. See, there you go. And that prints it out. And because it's in the same scope, you can actually, let's actually put it under there so you can see. You can see it still works. Now let's actually take this and move this into the second scope here. Notice how it still works, even though it's not in the same scope. The reason for that is twofold. First, we've set the variable, or we've declared it, I should say, before we've used it, so that works. And scope 2 is a subscope of scope 1, meaning scope 2 actually lives inside of scope 1. So anything inside scope 2 is accessible to scope 1. Same rule still applies though. You have to declare the variable before you can use it. See? Fails. So I really wanted to clear any misconceptions you might have about scope before we really deep dive into looping. Alright, so what is looping? Looping is like having a conversation with a 6-year-old child that keeps asking why. Oh, why is the sky blue? Why this? Why that? Why? Or an old person. Well, what's this? What's that? What's this? What's that? Not trying to disrespect young children or old people, but it's an example of a real-life loop that you've had to deal with. A loop is just a segment or a scope of code that's going to repeat itself. For I in range 10, meaning we're saying from 0 to 9 because it's going to make a 0-based index, you're going to append, x.append, the current number. This is called an iteration. Whenever a loop jumps back to the beginning, it's an iteration. In some languages, they actually used to have goto statements, but in Python, simple iteration. So let's run this, and you can see the iterations. We have 10 iterations, and with each one, our list is growing because we're appending to it. Pretty neat, huh? And if you wanted to not see the iterations, but just see the finished product, you would just take the print statement and throw it back into the first scope. And there it is in all its glory, our finished list. I'm going to actually bump that back into the subscope. So that's a for loop. Fors are very handy for going through a range or a list or a tuple or even a dictionary. Now we're going to do a little bit of fun here. We're going to say for I in x, meaning for each object in our list, we're going to print index is %d, and we're going to %d x, and we're going to say I minus 1. The index is 9, 1, da, 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 da. What that does is we're going through our list that we built here, and we're saying the current index is, now notice how it's not sorted, it's just whatever random order. So sometimes you may actually want to sort that and make sure. Now I shouldn't really call that an index, it's a position within the iteration. It's a little bit different. But it does kind of highlight that this is a 0-based array. For example, if you say I, and try running this, now it actually works the way you'd expect it. Index is 0 through 9. And let's say I minus 12, just to see what happens here. Notice how, boom, we're out of range. Out of range is a very common error for looping. Really what you need to understand with out of range is you've gone out of the bounds. There is no I minus 12 index. Now when you say I minus 1, what's going on here is another common misconception. Because it's a zero-based array, you think, oh, I got to get the position minus 0. No, this is an iteration. The iteration is automatically going to start at 0, which is why this works correctly. So those are some gotchas if you come from other languages. So what we've learned so far is that the for loop will take an array or a list or a tuple or even a dictionary, and you can iterate through them. And that's what we've really gone through here. If that's not making sense at this point, think of a for loop as a repetitive task. You know, you're a mailman and you have to deliver mail to 100 homes. So for I in range 100, 100 homes, deliver mail. That's what you're really doing. And let's actually do a dictionary. Why not? And we're going to actually have to make a dictionary. We're going to call it ages. And that's one thing I really like about Python is once you've done it once, it just kind of sticks. It's really hard to describe. You just kind of remember. Python, unlike most other languages, is small enough to actually fit in your head, meaning you're not constantly looking things up. So we're going to, let's actually space that out so we can see here. We're going to print. We'll say, whoopsie, %s is %d years old. Maybe, there we go. And we're going to say name, age. So what we do is we've got our dictionary, and now we're saying for name and age in ages.items, which makes an iteration list. We're going to run this. Brian's 40, Heather's 22. Now you see the real power of for loops. You can take a complex data structure such as a dictionary and make it do something meaningful. And now we're going to do the while loop. Now the bonus question for anybody out there wanting to score extra credit, what's the difference between a while and a for? Anybody? Anybody? For will always execute, while may not execute. While true. Maybe if I can spell this. We've got a lot going on tonight. It's prom night. We just had an earthquake. I've got a couple new video games. I just passed my PMP exam. So it's been busy. While true. What's that going to do if we run this? This is another common mistake I see people making in every programming language, not just Python. While true. Well, that variable, because that is a variable, is never going to change. So it's just going to keep going. You've just created an infinite loop. See, it just says too much output to process. And it's still running. I have to stop it. We have to interrupt it. And it just, I mean, there's thousands and thousands and thousands and thousands and thousands of these things. So if we'll say n plus equal 1, we're going to increment n. And we're going to actually just print out n and see what happens here. Oops, it's got to be on the same scope. There we go. And you see how that number just keeps going up and up and up and up. Eventually this program will crash because we're incrementing and it'll just go out of, what's the, oh yeah, it's a range check error that'll end up happening. Basically it goes into data types. Certain data types can only hold so much information and eventually it'll get so large it'll just stop. Or, I actually may be wrong because in some languages it'll actually revert back to 0 and start over again. So we can say while n is greater than 10. What's going to happen here? Well, when we run this, nothing happens because n is already 0. So this already is false. That's the difference between a for and a while. A for is always going to have that range that it's beginning with, where a while will evaluate the expression and may not actually execute. So let's actually just go back to true, our example of an infinite loop here. And we're going to actually do some processing here. And an infinite loop, in case you're wondering why you would want that, it's actually quite common if you're working with, like, say, a network connection or a file or something, and you want to monitor the bytes in. You just want to loop indefinitely until you have some sort of breaking point. That's what we're going to talk about next. So if is greater than or equal to 10, then we're going to break. Break means it jumps out of the current loop. It just literally stops and says, nope, I'm done. And we're going to actually execute that, and we're going to go print finished. Wow, I cannot spell. Finished looping. Let's run this. And now you see it says finished looping. And let's actually just print this out here. We're going to get a little crazy, actually. We're going to say if n equals 6, whoops, print 6 is awesome. Otherwise, well, actually, let's just continue. And I'll explain what continue does in just a second. All right, so here's our program. We're going to run this. You can see how it says 1, 2, 3, 4, 5, 6, 7, 8, 9, but it says 6 is awesome, and we finished looping. So this is the while loop in all its glory. We're incrementing our n, and then we're saying if n is greater than 10, we're going to break, which means it's going to break right out of this scope, right out of this loop. So it's going to go all this, it's going to say, I'm done with you, I'm no longer iterating, and it's going to jump here to finish looping. If, however, it's 6, we're going to say 6 is awesome, and we're going to continue. Notice how it doesn't just print out the number 6. What continue does is it jumps back to the beginning of the iteration. It just jumps right back. So anything down here will not get processed once that continue statement's there. Very key concepts you should know are break and continue. That's how you break and continue out of loops. A break will exit the loop. The continue will just start at the next iteration or the next step. Whew, that was a mouthful, and we've learned quite a bit. Some things you should bear in mind is range checking. I mentioned earlier that if we just kept incrementing this, eventually it would crash. Always check your ranges. So if you have a defined range, like a list or a dictionary tuple, you should almost always use the for loop because it does the automatic range checking for you. You don't have to say, if it's greater than the list count, exit, da-da-da. It's all done for you. All right, well, that's it for this tutorial. I hope you found this educational and entertaining. Be sure to visit my website, voidrealms.com. I've got the source code for this and other tutorials out there. And be sure to join the Void Realms Facebook group. I think we're just about hit the 200 some odd mark of developers in there from all different languages, not just Python. So if you've got like a Java or C++ question, or even like a Ruby or a Scala or something like that, there's people in there that know this stuff, and they can help. Hey everybody, this is Brian. Welcome to the 7th Python tutorial. Alright, we're going to dive right in here. Maybe if my mouse will actually work with me again. We're going to make the video 7, and we're going to call this one Fun with Functions. Gosh, I cannot spell. Alright, so what is a function? Whether you know it or not, you've probably worked with them before. We're going to use the word def, D-E-F, which is short for definition. And we're going to say do something. Now, inside of this definition, we're just going to say print hello world. And let's run this. As you can see, nothing happens. The reason for that is simple. A function, or a definition in Python, needs to be called, meaning this has its own unique scope. So if we actually, for illustrative purposes here, say start a program. When we run this little guy, you'll see start a program executes right here. But this definition does not, because we have to call this. And to call that, you literally just do this. Notice how you have to include these brackets here. There's our hello world. Now if we take these brackets out, what happens? Well, it doesn't do it because we're not actually calling it. At this point, we're just declaring an empty variable using that name. So you have to use those brackets. Now, let's make a little bit more of a complex function. Is that even English? A little bit more of a complex function? It's been a long day and I just got out of the gym, so bear with me here. We're going to say get list, and we're going to say max, and let's do this. X equal, let's see, I almost typed the word new. You can tell I'm tired because I was thinking in C++ for a minute. All right, so we're going to make a new list with a range in there. We're going to say for I in X, and we're going to say xi equals I times, let's just pick a number here. Let's say 5. And then we're going to return x. So what we're doing is we're actually returning a value, meaning this function, this definition here, is going to run, and it's going to return x, meaning it's going to generate x, and then it's going to return it. I keep saying return, but what does that really mean? So what we can say here is, we'll say my list equal get list, and we're going to say 20, and then we're just going to print my list. Notice how we're assigning the value. What we're really assigning is x from here. We're calling get list, and we're assigning the value. Let's run this. Uh-oh. What have we done wrong? Oh yes, we forgot our little semicolon there. Here we go. Beautiful. So there is our list right here. Now, quick discussion on scope. Remember how we said in previous tutorials where you had to declare a variable before you can use it? Well, the same thing applies with definitions and functions. For example, if we take this my list, even though it's in the same scope, and we try to do this first before the definition's been declared, we get an error. See, get list is not defined. It treats it like a variable. Pretty neat, huh? Now, this is an example of a single parameter. That's what this little guy here is called, a parameter. We're going to do a multiple parameter, and we're going to say def get animal. Let's not say get animal. Let's say get person. I'll say name age equal 0. And we're just going to print that was not good. You can tell I'm tired. And we're just going to say print. Now there's a couple things going on here in getPerson. First, we've got multiple parameters separated by a comma. You can have as many as you want. And this can be pretty much any data type. We could do a list, a dictionary, an integer, a string, whatever you want to do. And we're saying the person is, you know, whatever you want, and they are however many years old. Now you also notice age equals 0, meaning we're actually setting a default value. That does a few things here. Whoops. If we say we shouldn't call that get person. We should call it print person because we're not actually returning anything. So we're going to print person, and we're going to say Brian, and I am 40 years old. Go ahead and run this. The person is named Brian. They are 40 years old. Now, if we omit the age, what's going to happen? Person is named Brian. They are 0 years old. Notice how it used 0 because that is our default value for that parameter. We could also do the same thing as name. Notice how if you supply the parameter, it will use your supplied parameter. If you omit it, it will use the default. Now what happens if you don't use the default and you still omit it? If you said runtime error, you were absolutely correct. So why would you use a definition or a function as it's called? The reason why you would do this is you have chunks of code you want to run. For example, let's make a basic if-then statement. So we'll say, let's say h equal 8. Why not? If h is greater than 4, then we're going to print person else we're going to print person, and let's just supply some values here. Yeah, she's 212 years old. That's how tired I am. All right, 40. So what we're doing here is we're saying we have a variable h, which is 8. If h is greater than 4, we're going to print person Brian. Otherwise, we're going to print person Heather. So that's another example of polymorphism, where you can call this chunk of code based off this value right here. Let's run that, and sure enough, it runs Brian. Let's set that to 2 just so we can see it change. And there we go. Some little known issues. You have to declare it before you can use it. You should only add parameters that are necessary. Don't go crazy and have a function with 200 parameters. No one's going to use it. Some other things, make sure the name is descriptive. What does it do? Does it get a list? Does it do something? Does it print a person? Don't name it, my super awesome function that does I don't know what, because no one's going to use it. All right, well, that's all for this tutorial. Hope you found this educational and entertaining. Be sure to visit my website for the source code for this and other tutorials. And if you're interested in other languages, I have a whole bunch of other tutorials up there as well. Hey everybody, this is Brian. Welcome to the 8th Python tutorial. If you're new to programming, this is going to blow your mind. If you are an old programmer like me, this is probably the tutorial you've really been waiting for. Classes and objects. When we say a programming language like Python is object-oriented, what does that really mean? What is an object? An object is anything. We've worked with objects with strings, integers. You could argue that an integer isn't actually an object in Python, but Python actually wraps it with an integer object similar to what Java does. So we work with objects all the time. Wouldn't it be great if we could create our own objects? Well, we can. We can create a class. And what is a class? It's a blueprint. So we're just going to say class animal, and it's going to inherit, which we'll discuss here in just a second, the object. Notice how I said this is an object, because everything is an object. You're an object, your cat's an object, I'm an object. Don't call your girlfriend or wife an object. That's a conversation that won't end well. So we're going to say def eat, whoops. And I'll explain what self means in just a second. I just want to flesh this out a little bit so we can continue the conversation. And through the magic of copy and paste, we're going to make another function here. All right, so we have our animal class. We have a variable, and we have some definitions, or functions as they're called, inside of there. We covered that in the last tutorial. What is inheritance? Everything has to inherit from a base object. That's how everything is an object. So what exactly is inheritance? Well, we're going to make another class to illustrate that. If I could spell, a mammal is an animal. For example, you're a human, which means you inherit from mammals, which inherit from animals. So you can have multiple inheritance in here. Not so much true multiple inheritance in the sense that some languages have, but you can actually, get pretty complex here. Has backbone equal true, has hair. Just some definitions of what really makes a mammal a mammal. Def, grow hair. Notice how it says self. Self is a reference to the current object. And that's going to become pretty apparent here in just a second here. And if you're bald like me, you wish you could grow hair. All right, so now we've got two classes. The mammal class inherits the animal class, meaning it has all the properties of an animal. For example, I'm going to say cat, yeah, you knew that was coming, equals new mammal. Well, I shouldn't say that. I shouldn't say new. Sorry. I was thinking for my C++ days. I've had a really long day. And we're going to say dog equal mammal. Notice how they're both mammals. We're going to say cat dot name equal Shakes. My cat's name is Shakespeare. I call him Shakes for short. Dog dot name equal, and I used to have a dog named Molly. So these are two totally separate objects. They are instances of the mammal class. That's why I say class is a blueprint. This is not written in stone, meaning you can change it. You also notice how, even though it's a mammal, we're accessing the name variable from the animal object. That's what inheritance is. Mammal implicitly includes everything in the animal class because we're inheriting from it. That's how we can access name. And we can say, cat.eat, dog.sleep. And let's just run this, why not? So you can see the eating, sleeping. It'd probably be better if I put like the name. Yeah, let's actually do that just for illustrative purposes. I know you guys are smart enough to know what's going on here, but whoops. Don't know why I keep doing that. Oops. There we go. And let's just, because I'm a huge fan of copy and paste. We said we were going to discuss the self variable, and this is where it really comes into play. You can see how Shakes is eating and Molly is sleeping. We said cat eat, dog sleep. Self is a reference to the current object that we're accessing in memory. Remember, this is a blueprint. So there's two animals in memory, technically mammals. Each one of these has a different name. One is Shakes, one is Molly. So we have to access the self. Notice how we can't just say name. It generates an error. Unresolved reference, name. If we try to run it, boom, the whole thing explodes. So you have to access the current object. And there are other ways around that, but for sake of simplicity, this is what we're really going to discuss. Whew. So, How do you like that? Does that blow your mind or what? It is just dead simple in Python to make classes and objects and to inherit. So you can see how a class has its own scope, similar to a definition. And the definition is inside the class, so it's part of the class scope. Now, you may be asking the question, well, if it's in the same scope, like here, why do you have to use self.name? Python does that to protect itself. When you have a lot of objects floating in memory, you need to know where they go and where they belong. So that's something you just need to bear in mind. And to kind of solidify this, let's actually make a snake. You can probably hear my cat in the background. And we'll say, through the magic of copy and paste here. Darn mouse, I need to buy a new mouse. I really need to buy a new mouse. Say it with me, ladies and gentlemen, buy a new mouse. Kitty, go away. Last time she was in here whining, we actually had an earthquake. Earthquakes are very rare in Michigan. I live in Michigan in the United States. And Kitty, go away. It was a 4.0, and this cat is deaf, so she was like scared. I felt really bad for her. All right, so we're going to now cat.growHair, dog.growHair, snake. Notice there's no grow hair, because snake is animal, and that is why you would use inheritance. You don't want a snake to grow hair because that would just be creepy. But a snake, you know, has eat, has sleep, has everything in the animal class, but it has nothing in the mammal class. So now you understand how inheritance works. A mammal can inherit from an animal, but we did not inherit a mammal in the animal class. We inherited straight out of the object. Make sense? I hope so, because that's about the best description I can give you. That's all for this tutorial. I hope you found this educational and entertaining. There is more to come, and there's a lot more to objects and classes than what meets the eye. I really encourage you to do some research on your own. Some of the things we're going to discuss in future tutorials, and this is really just to kind of whet your appetite so you can get used to working with classes and objects, because that's really the power of an object-oriented language. Be sure to visit my website for the source code for this and other tutorials under Python, and join the Facebook Void Realms group. I know I've been beating that, just senseless, saying join the group, but there's a reason for that. There's 200 of us in there. A lot of times it's really difficult to get a hold of me, and then once you get a hold of me, my attention span's like a goldfish because I've got so many other messages coming in. Whereas you have 200 other programmers, some of them are more experienced than me, that are willing to help. Hey everybody, this is Brian. Welcome to the 9th Python tutorial. Boy, we're just flying through these little guys. I'm gonna make a new Python file and call it video 9. All right, and today we're gonna be working with modules and packages. So what is a module? Module is anything that ends in .py. We've been making these. You've made 9 of them if you've been following along my videos. So why would you make a module? Well, it's pretty self-contained. Like here's video 5. There's some code in there. You don't want to make one giant file. You want to break things into different files. So let's actually just make another file. Let's call this my module. Why not? And here's my module right here. And we're going to say class. Let's call this person. Inherits off of object. And we're going to make a definition here. Actually, no, we're going to make a variable. Name equal. And then we're going to make a def. Let's call it say hello. You've done this before. Hello, my name is, and then %s. I'm going to say % self name. So this is nothing new, but why am I doing this? What's this have to do with the discussion? Well, we've made a module like we've done in the past. Now we want to access this class and use it in a different module. We're going to say from my module, import person. Now we can actually use the person class. We'll say, I need a good name here. Let's call it person1 equal person. Did I not call that person1? There we go. Person1 name equal Brian. Really help if I had quotes in here. That was embarrassing. Can't even spell my own name. All right. Person1, say hello. Now, when we go to run this, hello, my name is Brian. So we have all the functionality of the person class, which exists in the my module file in the same directory, but we don't have to have all that code in here. All of it's included right here. It's basically the exact same thing as taking this and just copying and pasting it right there without having it cluttering up your file. But as you might have guessed, when you go to deploy this file, you also have to include anything that you're using. It's called a dependency. So that's an example of a module and why you would want to use a module. Now let's talk about packages. A package is a little bit different. A package is a directory, and we're going to actually make one here, Python package. And let's call this the ever descriptive my package, because I like working with my package. Now, those of you in the back row that are snickering right now, pay attention, this is serious. All right, so my package is just a directory with a special file in it, a special module called __init___.py. And when you open that, it just says author and then whatever because, you know, PyCharm put that in there. And in here, we're not going to really discuss too much in this video, but in here you can put special commands that will tell what to include and what not to include, and what's public and what's private, and you know, all sorts of neat stuff. So if your structure of your program starts getting really unruly, consider making a package. And let's actually add another file in here, and let's call this animal. You know, I'm sick of working with animals. Let's call it a car. All right, so we've got our car in here. And we're going to say def, well, not def, geez, class car. I am going to actually cheat a little bit here. I'm going to just take this thing. Nice sound effect there, right? And we'll call this car speed up. Let's call this set speed. And go. Going this fast. My eyes got a little blurry for a minute. I have the eye surgery. If you've been watching, you already know that. Sometimes my eyes get blurry. Kind of bugs me a little bit. Don't really need a name for a car. So, nothing new there. I mean, we've just got a package with a module inside of it. And we're just going to say, let me look at my notes super quick. From my package, .car, import car. So what you can actually do now is you can say from a specific package, a specific module, import a specific class. And then we can say my car equal car. And then my car set speed, and we're going to go 100. Why not? Let's run this and see what happens. And hello, my name is Brian, and going this fast, 100. Now, you might be asking, how can I actually import from this module when I don't really know the name? Well, I don't really care what the name is. You know, I want to just import everything in there. So if there's multiple definitions in here, so like we can say, let's actually make a truck. We're going to call this truck, truckle. There we go, truck. Set speed. So now we've got a truck and a car, and I'm not really going to check these out too much just because, you know, it would be, whoopsie, a waste of time there. What have I done? Well, I got a little too click happy there. All right, so now we've imported that. We can also say my truck equal truck. Notice how it's just automatically importing it. We didn't have to specifically say truck. And then we can say my truck set speed, and we're going to say 90. Why not? Let's run this little guy. Missing one required position argument. What did I do wrong here? Okay, now I feel very stupid. I just simply forgot the parentheses. All right, so there we go. So the car is going 100, the truck's going 90. So you can see how that works. Pretty interesting, huh? Now, something that's really going to kind of blow your mind here is, why am I showing you these other than you can just, you know, organize your code? Well, you need to get used to importing from other sources. Other people write modules. For example, if we click on external libraries, you'll see how there is a ton of stuff in Python 3. Just expand 3.4. These are pretty much all the packages and modules that you can really access, and there is just tons and tons and tons and tons and tons of them. Whew, there's a lot of stuff in there. And to kind of help with this, I'm going to actually post a link out here. I'll put it in the top of the file for you. We can go out there and you can go to the Python standard library. If you're familiar with C++, you know what a standard library is, but if not, I'll explain it. A standard library is all the functionality that comes with the language. This is all built in. Remember when I said Python's motto is batteries included? This is why. I mean, it's got just a mega ton of stuff. I mean, just about anything you can imagine. For example, I mean, you know, even JSON encoding, operating system, XML, Euro writers, input, output. It even has a graphical user interface, which we may cover in future tutorials. I mean, the list just is immense. I mean, it's actually grown very impressively. But believe it or not, Python's standard library is considered small compared to some languages such as Java. The Java framework is just massive. So I was going to actually do this in a different tutorial, but why not? Let's just do it in this one. I mean, we're on the subject. So we're going to import, and let's say sys. This is a pretty standard package. And we're going to just say print, print sys.version. So we want to know the system version. And you can say the version is 3.40, which is the current version that Python that we're running. Pretty interesting. Now, let's say, let's cover the dir command. We haven't covered that yet. Dir will iterate over pretty much anything. So if I actually import, let's say operating system or OS, what dir will do is it'll just print out everything that's available in there, and it's kind of long, as you can see. It just keeps going and going and going. And if you're in idle or if you're working with Python right on the command line, it's actually much easier. That's kind of what it's designed for. So like, let's actually run Python. say Python 3, and let's just say import OS, and we're going to dir OS. And you can see that's why it's there. It's for working on the command line. Now let's say there's something specific you want to know about. You can use what's called the help command. You say help os.write, and it says, okay, this is the built-in help for that module. And what it'll do is it'll say, write, and then you give it a file definition and data, and it'll output the bytes written. And it says writes byte to a file descriptor. So that, if you're ever stuck working with idle, is very, very helpful. But working with something like PyCharm, it's not that helpful at all. So just wanted you to be aware of it. That's pretty much it for this tutorial. Hope you found this educational and entertaining. Be sure to go over the Python standard library. Many times, if you're just kind of curious about something like readline, it'll actually have, maybe that was a bad example. Nope, here it is. They'll have example code right in here. So you don't have to go hunting in forums and Google and user groups. It's right in the library. So it's a really, really awesome resource that you need to, kind of go through. Make life a lot easier for you. Be sure to visit my website, voidrealms.com, for the source code for this and other tutorials. And of course, join the Void Realms Facebook group. I think we just eclipsed 200 users. A bunch of helpful people in there. Hey everybody, this is Brian. Welcome to the 10th Python tutorial. Man, we are just hauling through these. Call it Python 10. And what I want to cover today is exemption handling or error handling. Obviously, you've seen me make a few mistakes, and I'm sure as you've been following along, you've made a few mistakes. So how do you handle those mistakes? Well, we use what's called the KISS method, which is keep it simple and stupid, or simple/stupid. And what does that really mean? It means don't complicate your life any harder than it has to be. So we're just going to say def do something. And let's say we're going to n equals 0, x equals 5, y equal, let's just get creative here, x divided by n, print the value of y, just something generic here. And then we're going to, totally forgot our little brackets. That always bites me for some reason. Just so we can see that we're starting the program, and then we're going to do something. And let's run this and see what happens here. Oh no, we have an error. Shocker, we're dividing by 0. Well, this is a standard error message in Python, and I'm sure you've seen these before. And this is called the trace back, and what it does is it starts where the error originated. So like if we just go line numbers, line 13 in module, which means in the current module. If it was a different module, it would give you this module name would be different. All right, so line 13, do something. So we know instantly it's coming from do something. But it goes a step further and says line 9 in do something, and it gives you the actual code that's calling the error, line 9, this guy right here. And it gives you a description, 0 division error, division by 0. If you've taken any sort of rudimentary math class, you know you cannot divide by 0. I'm horrible with math, and even I know you can't divide by 0. It's just not possible. You can't do it. All right, so how do we get around this? Like, let's actually say number, and let's give the user the ability to enter the number. Right? So we're going to run this. What do we do again? Oh yeah, dirt. All right, so we get 1.1. We can change this. So we know our function's actually working. 2.5. So we're going to take whatever divided by whatever. Now, if the user enters 0, we're back to square one. We're going to have that same error again. We don't want that. So we need some sort of exemption handling, and it's in the form of a try exempt finally. And we're going to explain that. Say try, and we're going to indent this code. Notice how it gives you a little squiggly when you use a try. It's expecting an exempt or a finally. First thing we're going to do is accept, sorry. And we're just going to accept exception as E. And this is what's called a catch-all. And let's make that a little prettier. Something went boom. Now what try and accept does is it'll try this code, and if something bad happens, like a division by 0, it'll run this code, because this is a catch-all. This will catch any exception out there. So let's run this. And you see now it says something went boom, division by 0. So we have a nice pretty, something happened. And E is actually an object. So you can actually get into the args, you can do the traceback, you can do pretty much whatever you want. You can get the actual base memory on that. So it makes it a lot easier to work with. And notice how it didn't kill your program. Even though there was an error, your program keeps chugging along happily because you encapsulated it within a try except. So that's one way of doing that. Now a finally is a little bit different. Finally will always execute, regardless of what happens up here. Notice how Y never prints because we had a division by 0 error, but if we run this, you'll see finally I get to run. So even though there was an error, finally will run. And you don't necessarily need this code. You can just do a finally. You can do try finally. You would do this for the example if you had a file or a database or some resource. You would open it, and then when you're done, in the finally block, you would actually close that resource regardless of whether or not you had an error. Now, as you might have guessed, if you're been working with other languages, you can actually classify exemptions. So we'll say 0 division error. We'll say please do not divide by 0. And let's get rid of that. Now when we run this, notice how it says please do not div by 0 instead of the catch-all, because we've actually specified we want to catch 0 division errors and do this block. General rule of thumb, catch-alls are bad. You want to know what sort of problems are rising in your application. Another thing you should never do is simply pass. For example, runtime error, and we'll just say pass. If we've never covered pass before, what pass does is it just does nothing. It just takes the execution context and jumps right out. That'll create what's called a silent error. Well, actually, it'd been a better example if I had just done it in the division by 0. Let's throw a pass in there. Let's comment that out. There we go. That's what some people will do. They'll say if you divide by 0, just pass. That creates what's called a silent error. You never knew that happened. You never, 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 never want to do that. Repeat after me. Never do that. Reason why is because you want to know that error occurred. You want to do something with that error. You want to either log it or correct the problem. For example, please do not div by 0. You're telling the user, hey, choose a value greater than 0. One thing you should really understand about error handling is that you don't want to go completely crazy. As you can see, the error handling actually is bigger than the algorithm that we wrote. That's called defensive programming, and it's good to do that. But you don't want to make an exemption for every single type of runtime error that's possible, and there's a lot of them. So if we go out here, I was wondering what was that. Oh, stocks, never mind. If you go out here, you can see that there are a bunch of exemptions. And you don't want to make one for each and every one of these. For example, you don't want an OS error in that algorithm we just wrote because we're not dealing with the operating system. You don't want a stop iteration error because we're not dealing with it. So you kind of got to look at your code and say, what really is going to happen here? Well, division by zero is completely possible. But I would always, as a rule of thumb, put the catch-all in here, because if you don't and something else happens, you're going to get a runtime error. For example, let's do this. Let's just comment this out. And let's actually do, let's say we just expect a runtime error. And we're going to say print. This may not be the best example. Actually, it's not. Let's do OS error. There we go. Now let's run this. You can see how now our program crashes because we never captured that division by zero, either this way or with our catch-all. So you're going to want, at a bare minimum, a catch-all statement. Something went boom, division by zero. But it's always better to know what kind of errors you're getting into. That way you can handle them appropriately. Whew, that was a mouthful. It's been a long day. Thank you for watching. Please feel free to visit my website for the source code for this and other tutorials. Just go to Python, and I'll upload. I just did a bunch of videos. I think I did like 4 or 5 videos right in a row, so I'll upload all those before I go to bed tonight. Hey kitty, daddy's recording. Yes, I know, you're hungry. Visit Facebook and join the Void Realms Facebook group. There's 200 of us out there that are eager to help. And if you do join, be sure to offer help whenever you can. Nobody's an expert in any one thing, but if you have information and somebody's asking for help, just jump in there and leave a quick comment. Hey everybody, this is Brian. Welcome to the 11th Python tutorial. Today we're going to be discussing classes again with multiple inheritance and constructors. So let's make a class and let's call it animal, which is going to inherit the object class, maybe. There we go. And we're going to say the animal has a name, so default for that is going to be not named. Now in some older versions of Python, I'm not sure if it applies to the newest, but this would be a static or a static variable which is shared through all instances of the class. That can get very dangerous. Depending on which specific version of Python, if you make 2 animals and you change the name in one, it would also change in the other one, possibly. Not all the time, but you'll see what I mean here in a minute. And we're going to also create a constructor. And you notice how I do double underscore? And we're going to do init self. This is called a constructor. A constructor is called every time an instance of the class is created. Remember, a class is just a blueprint. You can make multiple animals from this class. The class itself is not an object. The class is just a blueprint for the object we're going to create. And when you don't include the constructor, and a constructor is automatically created for you in memory, and it's called the default constructor, which literally looks like this. It's just def init self pass, which means it does absolutely nothing. So why would you want to override? That's what happens when you make a function that already exists. You're overriding that function. Why would you want to override the initializer or the constructor? Well, in this case, it's because we want to actually do something when the class is created. So when an instance of this class is created, we want to do something. So let's say my animal equal animal, and let's run this. You can see how it called the constructor animal constructed. So you can put any sort of logic you want in here. Also, on top of that, even without an instance of the animal class, we're just going to call the class directly or the blueprint directly. You can see we can access that variable. So we have this variable floating in memory, but we have no class, or no object, I should say, that goes with that instance of that class. So that's why it's called a static variable. Now it's a little bit different. Some languages, when and some older versions of Python, I believe, when you changed it in one instance, it would change across all the instances, which is a bad thing. You don't want to do that. But in this case, it's static, meaning you don't even need an instance of the class in order to get it. So let's get rid of that. And let's make a couple classes here, because I want to really, build upon what we've learned. We're going to call this reptile, and it's going to inherit the animal class. And let's say reptile has scales. And I'm just going to leave that static keyword there so you know it's static. And let's say reptile constructed. And we're just going to make a few of these. Like we're going to make a mammal class, which inherits animal. Mammal has hair. And we're going to make another class, and let's call it class dragon, which inherits both the reptile class and the mammal class. Because, a dragon will have hair and scales, just because dragons are awesome. And we're going to say has wings equal true. Maybe if I can spell the word true. This, of course, is a static variable. And I'm just going to copy and paste this. That would be bad. Let's do that. There we go. Sometimes the Python indentation doesn't really work well with me. I'm not sure. I've spent most of my life in C++ and C# and other languages. Alright, so let's actually flesh out this dragon class a little bit more. And we're going to work with the deconstructor. Maybe. There we go. My mouse was in the way. Deconstructor is called automatically when the class is deconstructed. So you have a constructor when it's made and a deconstructor when it's destroyed. We're going to say self class, and let's go get the class name here. That way we can see exactly what's going on. I'm going to say print, oops, yeah, print, that's good. Start, and we're going to print finished. And in between here, we're going to actually do some work. So we're going to say my dragon, because I've always wanted a dragon, equal dragon. And we say my dragon name equal, let's call my dragon Sam. Why not? Just because it's a dragon. Now, when we run this, you see how the program starts. Dragon constructed, meaning we've made an instance of that dragon class. And we've set the name, which you don't actually see anything for that. And then dragon destroyed after finished. What happens is it gets here. The Python interpreter sees that we are now done with this dragon object, and it calls the deconstructor and destroys it in memory. That's called automatic memory cleanup. Some languages also use what's called garbage collection, meaning that object will actually stay in memory, but you can't really access it. And then over time, it'll do garbage collection and cleanup in the background. I believe it's also called pointer counting in some languages. So anyways, I wanted you to be aware of static members. Remember, you do not need it, an instance of the class in order to use a static member. So like let's just play around here. Let's say dragon dot name equal let's call it Heather, my daughter's name. She's always wanted to be a dragon, I guess. Print my dragon dot name. Let's just see what happens if we do this. I'm not sure if it'll change it or not. Yep. So now we've changed the name Heather, or we've changed the name to Heather in all instances of that class. So let's actually make another instance here. Let's call it dragon 1 and 2. So now we've got two instances. We've got the static member that we're going to change, and we're going to print dragon 1 and dragon 2. And just kind of to solidify this, I need a good dragon name. What's a good dragon name? Smog. Why not? So we're setting dragon 1 to Sam, dragon 2 to Smog, and then we're saying the static name set to Heather. What's going to happen when we run this? Whoop. Well, it would help if I put the equal sign in there. There we go. You'll see now how it's calling Sam and Smog. It's printing it out instead of the default Heather. What's happening there? We notice that if we don't set this right here, they're both Heather. So let's set it for one and not the other, and then I'll explain what's going on. You can see one is Sam. We actually set it Sam, and one is Heather. The one that's Heather is dragon 2, this guy that we commented out, because we're setting this static variable, meaning that exists in all instances of that class. So why does dragon 1 still say Sam if we just set it? Because when you're calling that, it will now treat that variable as a class variable instead of a static variable, or a member variable, if you will. So we're going to kind of wipe these out. I don't like wiping out dragons, but yeah, it's got to be done. Somebody's got to do it. All right, now we are going to actually modify mammal here. We're going to say self has backbone, because mammals have backbones, equal true. That's basically what it does. It'll take the variable name in this case, and it'll say self dot dot dot, meaning it makes it specific to that class. Some older versions of Python don't do that. It would change it across all of them. So that's another gotcha. So now we have a static variable and a member variable inside of this class. If we try to take my dragon, and you can see it has all these things. It even has the has backbone. Let's try and print that out. Let's do this for a few things here. Let's do like hair or wings or something. Let's do hair. And I'm not going to include the has in front. We know what we're talking about. So let's actually run this, see what happens. You can see how hair equals true. But suddenly we have an error. Backbone, object has no attribute, has backbone. Well, it doesn't make any sense, does it? I mean, when we put the period here, IntelliSense says it exists. So we know we're inheriting it. But why don't we actually have access? There's no attribute. It's because we now need to initialize the classes we're inheriting from. And that goes with the concept called the super. It's a super class. And by super, I don't mean that it's like Superman or it's super kind of like, you know, super spectacular. It just means that it's above it. What's it inheriting from? So we're going to say super, and we're going to say dragon, because we need to know that we're currently passing the dragon class. Self init self. And I'm going to put a little comment here. Must init the super. Let's run this again. Has no element backbone. Let's do the magic of copy and paste here. Mouse is acting up. I think I need a new mouse. And I'm not going to do it with animal, even though we could, because it really doesn't have a super. Its super is object, which is pretty much already initialized anyways. Now everything runs, and you can see backbone equals true. And that's because we've now initialized the supers. You got to go through the whole chain of what this thing's inheriting. And that's a good example of multiple inheritance with constructors. It can get kind of tricky here. What's happening now is you have a dragon class in memory, along with a reptile and a mammal, but they're superimposed, if you will, over this dragon. So now dragon has a member named has backbone. You may be asking, well, why don't you just put it right in the dragon class like this? And you can. But now you see the backbone is false, which is the opposite of what we wanted with the mammal class. What you're doing there is you're shadowing. You're shadowing that variable. You're saying that the inherited variable no longer exists, and you're going to use the one you've implicitly declared. Blah, I hate that word. Anyways, so just know that you have to initialize or call the constructor on your superclasses in order to get their member variables. Well, we've actually covered a lot of ground here. One final thing I kind of want to cover is how to add variables in the constructors. So let's do this. Let's say we want to do, we want to add an age in here. Self.age, because dragon's age, right? And we're going to set that to 0 initially, but we're going to just say comma age. Now the first parameter in every constructor is the self object because it's creating an instance of it and you can get self. So while it's being called, Python's actually creating an instance of the class and handing it to you in the form of the self variable. You're now saying self.age, meaning you're adding a variable to the instance called age. And we're just going to say it's the age parameter. And we're going to say years old. Why not? Because, you know, dragons do age. Let's run this. It says missing one requirement. Oh, it's because we never initialized it. And it's because it's a mandatory parameter. If we were to say 0, equals 0 I should say, now we're setting the default value for that parameter, and it would run like this, and it would just say the dragon is constructed at 0 years old, and if we add, you know, dragon 1's now 100 years old, you'll see dragon is constructed and is 100 years old. Let's rewind that, because I know it's probably a little bit confusing if this is your first language. What exactly is going on here? Well, we're calling the constructor. The self object is handed to us by the Python interpreter. It's an instance of the dragon class that we're currently in. Age is a parameter for the constructor. Some people call it default value. The default value is actually the equals 0 right here. We're saying that it's an optional parameter. You don't actually have to include it. That's why this works. If you do not include it, it's going to equal the default value, in this case 0. We could say every dragon is automatically 50 years old. And if we run it again, you'll see the one that we did not give an age to is now 50 years old. we're saying self.age equal age. That's a bit confusing. What does that mean? Well, what we're saying is self, meaning the current instance of this class. We're going to add a variable name age, and it's going to equal the parameter of age. And you notice how PyCharm automatically highlights it because it knows exactly where that's coming from. And you could name this something else. You could call it, just for illustrative purpose, Dragon Age. Why not? And then we'll name that there. And let's run that again. And you can see it does the same thing. So just know that when that was named age, self.age and the age were two totally different variables. And now we're just simply printing it out. And you can, of course, now access that. Print. And let's say %s is %d years old. Just because we want to do this, right? We'll say name and really kind of solidify this concept here. And we're going to name my dragon 2 Smog. Why not? Well, I think in the token books it's actually 2 Gs, but I'm just going to use 1 G. Let's run this. And you'll see how Sam is now 100 years old. This is what we're printing out. Now, what's really going on under the hood, and we're going to kind of wrap this conversation up because I'm getting short on time here, is when we add the name parameter, or the name parameter, geez, when we modify the name variable, it's no longer static, it is a member variable, and we're setting the age through the constructor, and we're just simply printing that back out. So if you followed along here, we're setting the name, which is all the way up in the animal class, and we're setting the age, which is all the way down in the dragon constructor. So questions, comments, concerns, feel free to drop me a line, or better yet, join the Facebook Void Realms group. We've just broken over 200 members, and it's usually faster to ask them and get like 20, 30 responses than to email me and wait 6 weeks for a, hey, I don't know, or did you try Googling it? So that's it. I hope you found this educational and entertaining, and thank you for watching. Hey everybody, this is Brian, and welcome to the 12th Python tutorial. We're just going to dive right in here. Today we're going to be talking about the path object. So first thing we need to do is import OS, or if you want to actually do it the correct way, you do from OS import path. Now what's the difference between those two? If you just do import OS, you can then do os dot whatever, which in this case would be os dot path, and then whatever command you want. But if you specifically import path from OS, you can then say path, that was embarrassing, path dot whatever. So that's really the difference between those two. So we're just going to say from OS import path, and we're going to actually get a path object here. So we're going to say print and %s, whoops, having troubles with my keyboard here. We're going to get the current directory here. Now if we run this, it's just going to print a little dot. Yep, the current directory is dot. And if you're not familiar with the dot notation, basically dot is always your current directory and dot dot is the parent directory. But we want to actually expand that and figure out what that really is. So let's try this. Print, and we're going to say abs path, or absolute path, is %s, and let's just go. So we're just going to say path, absolute path, and then we're just going to give it the current directory that we're in and just see what it prints out here. And we're currently in my home directory. I'm on Linux, so you see these slashes. If you're on Windows, you'll see like C program files or C users or wherever you're at. And that's kind of the beauty of Python, is it's very much cross-platform. Now we're just going to get the name. So we're going to say dir name. Run that. And you see the dir name is blank. That's not good. So let's get the base name from this. The base name is, of course, dot, because that's our current directory. So I don't want you to get thrown off if you see, curdir is returning a dot. Now, if we actually take this and make a variable, let's say, and let's actually make a string literal here. And to do that, you put an R in front of it. The reason why you would make a string literal is if you're like on Windows and you do this like C program files, yada, 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 whatever, blah, blah, blah. Each one of those slashes, if it's not a string literal, will be interpreted as what's called an escape character. Like /p, I don't remember what that is, but if it was like /t, that'd be a tab. /r would be, hard return new line. The only way around that would be to double escape them, where you do // which, gets kind of frustrating. Or you would just, make it a string literal by putting the R in front of it. I'm on a Linux machine, so don't really have to worry about it much, but I'll do it anyways. And we're just going to replace curdir with this, just so we can see the difference of what it's going to do. You see, now we have a base name, a dir name, and an absolute path. So that's really the difference between current directory and, when you hard code a path. Sometimes curdir is not your friend, and I just wanted you to be aware of that. We're going to really quickly finish up this tutorial. We're going to do exist, isdir, and isFile. So let's do So I don't know if there's any gamers out there, but I bought Skyrim Legendary Edition for like 15 bucks on Steam, so I've been playing that. It's a lot more than what I thought it was going to be. It's actually pretty in-depth. And let's say isFile. And what these commands are going to do here, they're pretty self-explanatory, but I'll go over them real quick. You got your absolute path. Let's actually run this. Okay, you got your absolute path, which as you can see is that. Your dir name, which is just your directory name. The directory, or the parent directory, I should say. The base name is the name of the current file or directory that you're in. Yes, it exists. That's very handy when you get into file operations. You want to make sure that file exists or doesn't exist. And then determine if it's a directory or a file. Whew. Well, that's pretty much all for this tutorial. Pretty easy one, but very important information that you should definitely understand. For the source code for this and other tutorials, visit my website, voidrealms.com, and we've got much more coming in the future. Hey everybody, it's Brian. Welcome to the 13th Python tutorial. We're going to be listing directory contents. Now, we want to get everything in a directory. Sometimes this is handy, and we can do that by, let's first just, my eyes are kind of bothering me today. I have to apologize if I make some spelling mistakes. I had my post-op, I had eye surgery, so I don't need to wear glasses anymore. But my eyes are a little fuzzy because they put these numbing drops and stuff in there. So we're going to print OS lister, and let's call it spath. I need to make a variable here. I'm just going to use the Python folder, just so I've got something to work with here that's a little interesting. And what lister is going to do is just give you a list of everything in there. And the problem is you don't know what's a directory, what's a file, what's really going on. So now we're going to get everything split. what do I mean by split? Well, we want to split this up into roots, directories, and files. Roots is very handy if you're on a Windows system. On Linux, it's really not that handy because you really only have one root for Linux and everybody knows what it is. Let's call it roots, dirs, oops, files in OS walk. Now what walk is going to do is it's going to literally walk that path, that directory structure, and it's going to determine what's a file, what's a folder, and what's a root, just so you have something to work with here. So we could, very easily say for, let's say, file in files, print, we're going to say file equal so we just want to print out the files. We want to ignore the directories just for whatever reason. Name in files. Well, yeah, it'd probably help if I spelled that right. Told you my eyes were bothering me a little bit. There we go. So there's all our files, and we could actually, through the magic of copy and paste here, we could print out the directories. So we could say the dir, all the dir and dirs. How many times are you going to say that in life? If my daughter was here, she'd be cracking up. She'd be like, dir. Anyways, so let's run that. And kind of whiz by real fast here, but if we scroll up, you can see there's directories in there. So there's a PyCache dir, and there's testers and things of that nature. Now, as interesting as that is, and that's probably done incorrectly, somebody out at home has probably already figured that out, we're going to actually comment this out, and I'll show you a much easier way to use the OS walk command. We're going to get only the roots, and we'll say, let's call it roots equal, we're going to use the next command. We haven't really covered that. What next will do is if you're in an iterator, it will jump to the first version or the first iterator in that group. Sounds complex, but it's actually very simple. It just has a list and it jumps basically to the first position. Iterators are a little different than lists, so it's going to be a tutorial on its own. And we're going to walk our S path. And we want to get the first list that it's going to spit out there. We're going to print roots equal, and let's just, not sure if that's going to print this out right, but we're going to find out. Run that. Yeah, so there's our roots. Now the root is the root path that we're starting off with here. And through the magic of copy and paste, we're just going to very quickly go only the dirs, D first, geez, that was bad, only the dirs. And we're going to get the first one. Man, this eye surgery, I'm telling you. I had to PRK, not LASIK. So the recovery time is like months and months. I'm on 1 month and 2 weeks, I think. And I can drive and I can see, and you wouldn't believe me by watching these tutorials, but I can type. But sometimes my eyes get a little weird and I gotta stop and really focus and figure out what I'm doing. It makes video gaming and coding very interesting. So as you guessed, we're getting only the directories and only the files, and we're just going to spit those out here. So you can see there's your directories in a nice neat list that you could iterate through, and there's your files that you can iterate through. And from there you could actually, get extra information like the file size using, I think, OS path and a few other things. But just wanted to make this a nice, clean little tutorial on how to walk through a directory. That's all for this tutorial. If you found this educational and entertaining, be sure to visit my website, voidrealms.com, for the source code for this and other tutorials. Hey everybody, this is Brian. Welcome to the 14th Python tutorial. Today we're going to be writing a file. So you can see I have this beautiful test directory all set up with nothing in there. And we're going to actually make a file. So we're going to say import OS. And we're going to just spath, why not? And I would need to actually set the path here. And I'm just going to make it a text file. That way it'll open up in my text editor. Now what we need to do is do a bit of magic here, if you will. So we're going to make a function. And we want to actually detect if that file already exists. So if, whoops, and we're doing this because I don't want you to accidentally like overwrite some important critical file, like your vacation folder, your vacation pictures or your resume or your homework or whatever. It would not be good if you did that, because once it's gone, it's just gone. It does not go to your recycle bin or anything like that. It's just gone. All right, so if it already exists, then we're going to just return out and not do anything. Otherwise, what we're going to do here is we're going to say f equal open, and we're going to give it the variable s file. We're going to give it a w for write mode, and we'll discuss modes here a little bit in depth. And we're going to say try. We're going to try writing to that file, and we're just going to say hello world rn, and we're going to say this is a new line. That's something you'll get throughout your programming career. You'll see the /r/n. The slash is an escape character. And I think we've talked about that in the previous tutorial, where if you're doing on a Windows system like c:/, it'll actually error out because it's going to escape the string. Now what it does is it actually takes this next little digit behind the slash and turns that into a special character. Like /r is a return, makes a new line. Or I'm sorry, it's just a hard return, and then n is a new line. So whenever you do this on the keyboard, you hit the enter key. That's actually 2 characters in memory. I think it's like 10 and 13. I might have those flipped around, but /r/n, carriage return line feed. It's actually pretty common. And we've done error handling before, so we just want to print out if there's an error. That way if you have a boo-boo, you can try and figure out what's going on. And finally, this is a good example of why you have the finally block. If f is not none. None in Python is a special keyword that means it's not there. There's just nothing to it. It's never been assigned. So, that's a mouthful. So what we got here, let's kind of go through this, is we have our function, has a variable that we're going to pass to it, which is going to be the file name. If the file exists, it's going to print out a message in return. Otherwise, it's going to open the file, which will then create a blank file on the hard drive. Then we'll try to write to it. If there's an error, we'll print out the error, and then finally we will close the file. One thing you should get in the habit of is called flushing. And it does, sadly, exactly what it sounds. It's just like flushing a toilet. It flushes everything from memory down into the hard drive. When you're creating a file, literally what you're doing is you're creating data in memory and then taking that data and shoving it down into the actual hard drive, the actual hardware. So flush literally flushes from the memory to the hard drive. So I wish they would have picked a better word for that, but it is what it is. So we're going to just write file, spath, and let's run this bad boy and see what happens. And it says process finished, exit code 0. I probably should have put like a little, hey, we wrote the file in there. But you can see there's our little test file. And if I bring it out here, you can see hello world, this is a new line. So that's our file. Now if I attempt to run this again, file already exists. So it's going to, whoops, I just bumped the mic, sorry about that. It's going to get here, and then it's going to return out. And that'll keep you from accidentally overwriting a file. Now, notice how if we just comment this out and run this again, we're doing no intrinsic checking to see if that file exists. We're just going to overwrite it. And whoops, you can see in my little notepad editor, it's saying, whoa, this file's been changed. What's going on? And let me see if I can actually drag it over here. Yeah, there we go. The file on disk has been changed. So not all text editors are smart enough to do this, but fortunately the one in Ubuntu is. So we're just going to cancel that. So it detected there was a change. Now when we go out to the actual file and reload this, you see it's the exact same thing. That's write mode. Write will completely delete the file and start over. If you wanted to append the contents, you'd use an A for append. And now if we run this, let's say a few times, I'll click it 3 times, why not? And let's run that. You'll see that we have 3 distinct things. Now we didn't put the hard return in there, so it's just going to start right where it left off. If we would have put the /r/n, it would have actually, broken it out like this. So that's the difference between append and write. That's all for this tutorial. I hope you found this educational and entertaining. Thank you for watching. Feel free to visit my website, voidrealms.com. Whoopsie. And that way you can actually get the source code for this and other tutorials. And be sure to visit the Facebook Void Realms group. There's over 200 programmers in there that can also help. Hey everybody, it's Brian. Welcome to the 15th Python tutorial. Today we're going to be discussing reading text files. And this is actually a pretty common thing you're going to have to do throughout your career as a programmer, is read a text file, or specifically read it one line at a time. So we're going to show 2 techniques here. One, how to read the entire file, and help if I spelled import correctly. So to read the entire file, we should probably actually, do a little bit of error checking here. And I'm not going to go through making a function with the try exempt finally, because we've done that before. I just want to very quickly do this and show you how it works. So we're going to say if we'll call it sPath. Let's actually make my variable. Let me get my file name here, the file we've been working with. And you can use just pretty much any file, but it should be a text file. If you get a binary file, then we'll be covering that in future tutorials. But the difference between binary and text is that text has things that's human readable, where a binary just has a bunch of numbers in it. So like a program, well, like PyCharm that we're working with, would be a binary file, where an email would be an example of a text file. So if we're going to say if it exists, say with open sPath as f. Now what the with command does is it says take an object and with that object do something. So we're saying with the open object, or the f variable more in this case, because we're returning something from that. Was that confusing? Let me explain that a little better. With an object we're going to do something. So with, and then this function is returning an object we're going to call f. So with f we're going to do something. Should be a little clearer when I do this. When we read the entire file, we're just calling read, and it's going to read everything into memory. Now, that can be good and that can be bad. It can be good if it's just a small file and you want the entire contents to it. See, there's the entire contents of this file. It can be bad if you have multiple lines and you want to do something for each individual line. And there's really, with any language, multiple ways to do this. And we're going to just grab that, make sure it exists. Otherwise, if it doesn't, it'll give you an error message. And what we're going to do here is we're going to get all of the lines. So what we're going to say is f dot read lines. Now when we run this, you'll see it returns this nice list. The problem with this list is it's got these /n's in there. So it's got a new line in there, and we'll have to actually strip those out. And you would do that by, well, let's actually call that line in lines. And let's back up here a little bit here. Lines equal f dot, you know what? Let's just do it the easy way. So for f in read line, or for line in read lines, we're going to print we're going to strip that line out, and we're going to strip out the escaped character there. And let's actually put something in here so we can see that we're doing something different. There we go. So we're going to read the lines, and you can see how we're stripping them out. If we don't, if we just print the line itself, it's going to look a little weird. And let's demonstrate that. You can see how it's got these new lines in there because we didn't strip out that new line character. All right, so, and there's an even better way of doing this. Reading the actual lines one line at a time. So what we're going to do here is we're going to say, do this, and we'll say line equal f dot read line. And this is just going to read one line out of there. And we'll say while line, meaning while we have a line object. Remember, everything in Python is an object. So if it's nothing, it's just not going to execute this code. Remember, we've discussed the while loop in previous tutorials. We're going to print this out. We're going to say line equals, and then whatever processing we were going to do to this. And let's actually throw that here. We'll say line, and we want to strip out any white space. If there's, like extra spaces before or after, we want to strip those out. Just because. And then of course we want to say line equal f read line. And what this will do is it'll advance to the next line. So let's discuss this a little bit here. Actually, first let's run it, make sure it actually works. Yep, there's a problem. Okay. Indentation, gotta love it. All right, there we go. So we're reading the lines one line at a time, and you can see how it says line equal, and then it's got our line, and we've stripped out any white space. I know it doesn't look like it. You see that little blank space that's actually added by PyCharm. So what we're doing is we're saying if it exists with open as f, meaning we're going to call the open function and return an object called f. We're going to read a line. If that line object exists, because readLine will return none if it's just nothing, it will, if we get that object, then we're going to go to this while loop, while line is true, basically. We're going to print it out, and then we're going to get the next line. Whew. That's a mouthful. So those are 3 handy ways to read a text file. I typically get inundated with, hey, how do I read a file one line at a time? Well, that's probably the best way to do it. As with any programming languages, there's multiple ways to do it, but I think that's one of the more efficient ways. You should note there's really no error handling in here, so you'd have to encapsulate this within the try block. That's all for this tutorial. Hope you found this educational and entertaining, and feel free to visit my website, voidrealms.com. Let me bring that up here, voidrealms.com. For the source code for this and other tutorials, just go to tutorials and then Python. And join the Facebook Void Realms group. There's over 200 of us in there that are willing to help. Hey everybody, this is Brian and welcome to the 16th Python tutorial. Today we're going to be covering binary files. Originally I was going to split this up into two videos, but I think I'm just going to do one just to make it a little faster. If you're wondering what a binary file is, it's a computer file that is not a text file. That's the very descriptive Wikipedia article right here. What does that mean exactly? Well, a text file is meant for humans to read and write. I'm sure you've opened like gedit or notepad or text on Mac or whatever, and you've just written yourself a quick note and saved it. Well, if you examine the contents of that file, it looks exactly how you typed it. That's a text file. A binary file would be like, well, an image or a database or this web browser, any executable, or any type of file you can imagine. And here's an example of what it might look like in a hex editor. You can see their hex values. And it gets pretty complicated, and there's some computer classes you should probably take. Like you should learn like what a bit and what a byte is and what a nibble and all that stuff. But we're not going to really cover that because I don't want to bore you with the details. And if you're watching this video, you probably already know what they are. So if not, you can go out and just learn on your own. Google's awesome like that. We're going to call this the very descriptive video 16. And we'll call this binary files. So why would you want a binary file? Well, let's say we have a list. And in that list we have some numbers. Let's just say 12, 30, 34, whoops, 34, say 200 and 255. That's our list of numbers. And we want to write those numbers to a file. And we want to be able to read those numbers back exactly as they are. Well, we're going to make our string literal here, and I know the path to my directory. I'm going to name this test.txt. Now I know somebody out there is like, whoa, hold the phone here. Test.txt, isn't that a text file? Actually, no. The extension does not denote what type of file it is. It's just a name. The contents of the file are, well, up to you. Typically, you'll get what's called a header inside of a file. And let's just, for whatever reason, say this is the header. So if you ever open like a JPEG or a bitmap or something in like Notepad, you'll actually see the header. It'll say like, image dash JPG or whatever. That denotes what type of file it is. So anyways, we're going to make a buffer. We'll call this, we're going to call the bytes function. And what this does is it turns our list into, well, a list of bytes. So we can actually print let's run this and see what happens here. You can see our list looks nothing like what we have up here. It's B and then this little guy and then /XOC. What's going on here? Well, what it's doing is converting it to bytes in memory, hence the little B notation in front of our string. That says this is a byte string instead of a literal string or a real string. And this is hex. If you don't know what hex is, there's a whole science behind it. I won't get into it, but it's just a different way of displaying the number. Like XFF, that's 255. So you can see it gets kind of interesting. Now, let's actually take this, and we're going to write this to a file. We're going to say open, and we're going to say binary write. Very important that you say binary write. If you don't, you may encounter an error. Now we're going to write that buffer out to the disk. Run this again. Process finished. So let's go look at this little guy here. And if I just drag it over here, you see it's got this gobbledygook. What is that? Well, that is the, in my case, gedit. Yours might look drastically different depending on what you're really looking at. It's going to base on character encoding. Well, I was trying to get it to change, but it didn't. But anyways, it may display it differently. It may show like a little happy face or like a little Y with 2 dots over it or whatever. But that is an example of a binary file. You're not meant to read this as a human being. This is strictly for the computer. So if you've never seen a binary file, congratulations, that's your first. Now we're going to actually read it back. And this is why I was saying I'm just going to do it in one video, because this was originally going to be 2 videos, and what's the point? So let's actually just print. We're going to read it back. And let's say with and while I'm typing this, I'm just going to open this with binary read. But while I'm typing this, be sure to check out the Void Realms Facebook group. There's over 200 of us in there, and we just try to help each other out. So let's go buffer equal, oops. And we want to read, you can read all of it. We're going to read a maximum of 16 bytes. If you just do read, I think it's just going to read all of it, but I just wanted to demonstrate that you can limit how much you're going to read back. And now we're going to print. Whoopsie. Not doing good today. My brain is just not here. I had a pretty long day at work. I'm sure you guys know how that is. So we're going to take that buffer. Now, you may be saying, well, don't you have buffer up here? Actually, I do, but I'm changing the variable. Because I'm reading it, I'm replacing it in memory. It's not a popular programming style, but it's actually a very common one. For I am buffer. Now I'm just going to loop, and I'm going to print out. And we're going to do what's called a cast. If you're not familiar with a cast, I think we've covered it in other videos. It's just converting one data type to another. So we're just converting it into an integer and making sure that it's going to display correctly. Let's run this and see what happens. So you see the length of the buffer is 4. We've read the file. Notice how we said read 16. If it was longer than 16, it would chop it off at 16, and you'd only get 16. So if that file had 300 bytes in it, we'd only get 16 because we said limit it. And the length is 4, so we know we got 4, and sure enough, our values are 12, 34, 200, and 255. Now, why would you want to write a binary file? Simply put, you can pack a lot of information into a binary file that you couldn't with a text file. For example, think of a picture. You've got like a 600 by 600 picture. Well, take 600 by 600, that's how many pixels are in there. It takes even more bytes to represent that picture because you've got different color scales, you've got the size of the image, the header, all this information. And it actually gets into what's called a structure, which we're going to cover in the next tutorial, which is a very common theme for binary files. Well, that's it for this tutorial. Pretty painless. Be sure to visit my website, voidrealms.com, for the source code for this and other programs. And go out to Facebook and visit the Void Realms Facebook group. Hey everybody, it's Brian. Welcome to the 17th Python tutorial. It kind of screwed me up. My notes we smushed the last 2 together into one video, so it kind of screwed me up a little bit here. But today we're going to be talking about binary files and structures. And to kind of help me with that, we're going to look up on Wikipedia the JPEG file format. You're all familiar with pictures out on the internet, like this cute cat. Everybody knows I love cats. So what really makes this file? How do we get that image on the screen? Well, you use what's called a structure. And I used JPEG on purpose because it's a very complex data structure. And if you just kind of scroll down here, you don't have to read all this, but just understand. Remember how we talked about, hex FF is 255 in the last tutorial? That's the start of the image. So you have this nice structure here to work with. This is the common MPEG marker. And what this is just simply a data structure. You'll hear this in different languages. You'll hear it called a head, a header, a struct, a structure. In Python, they're just structs. But they're very easy to work with in Python, and they're very painful to work with in some other languages. Now, what would you use a struct for? You can see how this is just denotes something. It's like the size, the progressive, whether it's got Huffman tables, quantitative or quantization tables, define restart intervals, scans. I don't expect you to know any of this. What I'm getting at here is JPEGs are actually very complex. You'll have this 8 by 8 subimage. That's right, subimage, meaning a picture can actually be made up of other pictures. And those are structures that are read, you got it, from a binary file. Now you start to understand a little bit more about why binary files exist. You can pack a lot of data into them. I almost say like 10 times the amount of data you could in a simple text file if you try to describe something. And you can have these beautiful structures which are very easy to work with. So we're going to actually not mess around with images because it's a little too complex for us right now, but we're going to make our own structure. So let's actually go in here, go new. Did I call it video 18? Ah, I did. This is video 17. My bad. Like I said, my notes just totally video 17. There we go. We're going to call this struct. Now, first thing we want to do is I'm going to put a link in there for when you download my tutorial off my website that you can very quickly go out and read about this. But we're going to, from struct import star. What's that? What that's really doing is we're taking the struct and we're importing everything inside of it, that struct package. We've done this before. And we're going to make a string literal here, which is, of course, the path to our file. And yours will be whatever, C, my documents, etc., etc. Little quick rant. It just bothers me. I mean, I used to love Windows, and I got a Mac, and I got into Linux, and it just bothers me that Windows is different than everything else on the planet. It's like, why can't everything just be the same? So, with a structure, we need a format. What does that mean? It means you need to understand what you're putting into that structure. You don't just willy-nilly start throwing bits in there. I mean, crazy things will happen, right? So with a structure, you have two concepts, packed and unpacked. Pack is when you're packing it down to store it into a file or like into a box. Think of it that way. You're going to package it. And unpack, well, you guessed it, you're pulling it back out of that file and you're going to do something with it. So I'm going to say packed equals pack, and this is from the struct package. Now, first thing you need is the format. Then you need some data. You notice how there's a star there, star values. What that means is it accepts one or more. We can just go infinity and beyond. So if you ever see star values or star something, you know that you can have multiple in there. So we're just going to say 1, 2, 3, why not 3.14? So that's our structure. Integer, integer, decimal. That's how that reads. So integer, integer, decimal. That way the struct package, particularly this pack function, knows exactly what we're storing. We're giving it a format to work with. If we gave it the incorrect format, it's going to start squawking, you're going to get all sorts of errors, and it's going to get ugly. This is a pretty dumbed down example of struct pack. You can find some very complex examples out on the internet, but I really wanted to dumb it down just so we understand what's going on here. Now we've got our packed structure here. So let's just print this out just to see what it looks like. I'm a big fan of show and tell. And you can see there's our structure here. Holy moly, look at that. That is a whole lot. What's going on there? Well, if you paid attention during your computer class, you know that an integer, at least on my platform, is 4 bytes. So there's 1, 2, and 3.14 is right there. So that's what's going on, is the packed function turns this into a binary string that's, essentially Python's going to push it down onto the disk. So we're going to say print writing file. Let's get that out of there, put that there, just because I'm picky like that. With open str file, and you guessed it, we're going to binary write as f. Now, what we're going to do here is we're going to write this out. And we're going to say f.write bytes, because we need to convert this into, you guessed it, bytes packed. And what that does is it takes our binary string and converts it into, you guessed it, bytes, and then writes it down to the disk. Now we're going to print reading the file. Whoopsie. There we go, reading the file. And we're going to say with open, and you guessed it, we're going to binary read. I'm going to Europe this summer, so I'm kind of nervous about it. I'm going to go to France, specifically Paris, Italy, Spain, and I don't know where else we're going. It's kind of a surprise. We'll find out. But I'm going to be gone for 2 weeks, so it's going to be interesting. So we're going to just read. Now, you notice how from the last tutorial we put a 16 in here. This time we're not doing that. We're just going to read everything, the entire contents of the file in there. Now, if you knew the length of your structure, you would actually say only read a certain amount. For this example, I'm just going to read everything. And we're going to say unpacked equal. And you guessed it, we're going to unpack that. Needs a format. And we're going to give it the buffer. And then we're just going to print. Probably help if I actually did something with that. There we go. Whew, let's see if this thing runs. All right, so we've written the file. We're reading it back, and sure enough, we get, you guessed it, 1, 2, and 3.14. Nice. Let's see what that looks like out on the disk. And there is our beautiful file in all its glory. It may look different on your screen, but that is the gist of it all. So that is a struct. Now, you know the basics of why you would use a struct. Now you can think of certain projects that you would do, like if you wanted to store somebody's employee ID and their age or something like that, you'd make a nice structure and you could, pump these out to the file. That's all for this tutorial. I hope you found this educational and entertaining. Thank you for watching, and be sure to visit my website, voidrealms.com, for the source code for this and other tutorials. Hey everybody, it's Brian. Welcome to the 18th Python tutorial. We are going to do something that's going to blow your mind. Are you ready? Serialize objects. Ta-da! What does that mean exactly? Well, we've all done this before, right? Where you made a class, and let's just make a generic class here. And we'll say age equals 0. Yeah, we've done this before, but I'm just going to flesh this out a little bit here, just because. And let's name equal unknown. Unknown, geez, can't spell. And let's just make a function here. So when I say we're going to serialize an object, what am I talking about here? Are we turning into a serial killer or something? Or are we making some sort of hybrid robot out of our computer? No, actually, you've made classes before, and you've filled in the data, and you've probably thought, you know what? How do I save this for later? How do I take this class that I'm working with here and actually make it so that I can store it to disk and load it later? And that's what we're going to do. And if you've never heard of this before, it's called object serialization. And a lot of programs actually do this. When you're in a video game and you save your file, that file is just a class or collection of classes, and it gets serialized to the disk. The benefit of that is you don't have to write a lot of code to load all this stuff back in. You don't have to, like, you completely ignore the previous videos on binary and text files that we've done. You don't need them. You can just simply serialize the object. You do that by importing something called pickle. Now, I have to pause because usually when you import a pickle, that's kind of a weird thing, and your friends look at you and there's that awkward moment, and then you have to really explain what's going on. Why they called it pickle, I have no idea. It's a funny name, and it actually cracks me up every time I use it. So we're going to test our object. Now, what this will do behind the scenes here, it will make the object, and then it will convert all that into everything that you've learned in the previous tutorials about structs and packing and unpacking and reading and writing binary files. It'll do all that for you, so you don't have to worry about it. We're just going to flesh out some things here. My name's Brian. I'm 40 years old. Sometimes I don't know if I want to say that, but whatever. Wisdom comes with age. So let's test this out. Let's actually make sure our little class here works. Hello, my name is Brian. All right, so let's actually, just because I'm picky like that, I want to be able to see all the information. Actually, you know what? No, I don't. I'm going to be less picky. That's my goal for this year, is be less picky. Anyway, so we're just going to leave it like this. Now we're going to write this to a file. And test.txt. I had an interesting email. They know I'm a security nut, and they're like, don't you feel a little weird, reading and writing files and throwing it up on YouTube and having everybody looking at your hard drive? And I'm like, well, not really. I mean, there's really nothing exciting on my hard drive. And this is just my little play box where I record videos and do nothing else. So anyway, so we're going to open the file, and you guessed it, we're going to binary write. Now, this is where pickle becomes beautiful. You ever seen a beautiful pickle? Well, you're about to. Pickle is going to take a dump. I know some of you, especially if you're watching this in like a high school classroom, are probably laughing really hard, but that's actually what it does. Pickle dumps the data to the disk. So we will dump that out. We're going to print pickle. Let's say the pickle has landed. Just because I've had one of those days. I need some humor. Now we're going to read that file back in and load it and actually create a new object in memory. This is where your mind is just going to explode. You're going to go, what just happened? So with open file, let's actually do the correct one. We're going to, of course, binary read as F. And we're just going to say O equal pickle load. Now, you need to do a few things here. We need to take our current class that's in memory, that P, and we need to dump it to our file. So what's going on, if you're following along here, is we have our class called person, making an instance of that class in memory, and just adding some variables and stuff like that, and I tried not to be picky. We're taking that and dumping it to a file. Pickle's taking a dump. Probably help if I had the right version of dump here. There we go. And see, it's taken P and it's putting it in F. F is just the file, so don't get confused. P is the instance of our person, F is the file, so it's dumping the person into the file. The pickle has landed, will be printed. Now we're making a new variable, and pickle's going to load that little guy in there. And I actually did that wrong. There we go. Pickle's going to load the file in here. Now some interesting things are going to happen as soon as we do this. Let's actually say print O, just so we can see what's going on. And let's run this. Now, hello, my name is Brian. The pickle has landed. Now you see this __ main person object at. What in the heck is all this? Let's actually go out and look at this file. This is our file out on the disk. Now, it may look different on your screen depending on what you're looking at it. I'm using gedit because I'm on Linux, and this is trying to interpret the hex values. This may come up as a blank document. This may come up as a bunch of weird gobbledygook and smiley faces. It just depends on what you're looking at, right? But this is, you guessed it, a binary file. Now you can see some things in there, like you see my name. So you know something's going on here. And you see it says name. So you know that it's actually doing things. And there's age. The tricky thing of what this is really doing here is Python is a dynamic language, meaning you don't have to declare a variable type. It knows intrinsically what type of variable it is. It does that by, you guessed it, putting a class type in there. Person, which inherits object, at, and then this is the memory address of where this actually lives on my computer. Neat. So let's actually continue with this here. Now, if you try to work with that object, like let's say O dot, notice how IntelliSense does nothing for us. That's because PyCharm isn't smart enough to know what type of object that is, because it has no idea what's on that disk. So you can do some things, and I'm going to actually put this link out here because I found this really awesome link. If you're using PyCharm, otherwise just ignore the link. But what it is, it's type hinting in PyCharm. Some simple ways you can get PyCharm to understand what type of information you're working with here. So, and this is all built into Python, so you don't have to worry about learning some proprietary thing. If is instance, and you're going to say O, and we're going to say the person class, then we're going to print O.name. Or actually we could say O.call the function. Watch this. Hello, my name is Brian. None. No idea where that none came from. Let's actually do dot, whoopsie. Let's see the age. Make sure the age actually loaded. There it is, 40. Just put the name in there. So what you're really seeing here, now it's going to kind of bug me. I'm wondering where that none came from. That will be your homework class to tell me where that none came from, because I don't have time to look into it right now. I've actually got a rush. But that's what's going on. So you can create your classes, fill them with information, serialize or save them to the disk by making pickle take a dump. And then later, when the computer starts back up and the person starts your program, you can load those back into memory exactly how they were before. The beautiful part about pickle is it intrinsically works with all of the Python types. So it knows. It doesn't have to guess. It just knows. Whew. That was a pretty awesome tutorial. Sorry I fudged a little bit, and I'm really wondering where that none is coming from. That's going to be my homework to figure out what I did wrong here. None. I will figure that out. But if you figure it out before me, post it in my YouTube channel. In the meantime, be sure to visit my website, voidrums.com, for the source code for this and other tutorials. And I know I've been beating it to death, but be sure to join the Facebook Voidrums group. There's 200 of us in there. The reason being, I'm not always available. It can take days, weeks, months to get a hold of me. My inbox is continually slammed. So if you send me an email and you really want some feedback, it's going to take a while. So join the Voidrums Facebook group. Ask your question. 10 people are going to jump on it and instantly start giving you ideas. So that's it.